Hello and welcome back. So those who are joining right now, let me know. Yes, I am here. Aditya NK, I am here. Already started the live. Check. Yes, class is running. Yes, hi. Class started, Mohi. So yes, so first of all I will show you, just give me a moment. I said I will show you the tangent table once more. Those who want, just give me a second. Yes, this one. So those who are wondering how to check sine cos table, so this is the table published by NCERT. It will be available to you during your exam. Okay, natural tangent and natural sine is the most important thing that you need to know. Now always I tell my students that only one thing you need to be worried about is these values. Okay, so now you might be wondering, sir, so some dashes are there, some dots are there, so do not worry about it. So 1.0724 is the value for just a second, is the value for tan 47 degrees. So tan 47 degree, tan 48 degree, tan 49, 50. So you just need to take these values. In case you are finding say tan inverse, for example, during our question we found some 2 point some value, okay, and that was coming out to be 70 degrees. So you just need to see that closest possible value of your calculated result. So for example, you are doing tan inverse say 2.7. Now tan inverse 2.7, if you see in the table, the closest value is 70 degrees. So you just need to write, okay, the closest possible answer. So you need to write this, okay, nearly equals to 70 degrees. Now if you see that here we have 2.7475. So don't worry about it. If you are getting 2.69 as well, the closest whole number will be 70 degrees. You can take the closest whole number and you can find the closest degree to that. Okay, the accuracy of 69.5 degrees or 69.9 degrees, that is not required. Even if you are doing the whole number, closest number, that is sufficient. So if you are suppose during the sine table we solve sine 50 degrees, okay, sine 50 degrees. So you just go to the table of sine. Okay, so you will be mentioned natural sines, natural cos, natural tan, tangent. So you just need to go to natural sine and then you just need to find sine 50 degrees. Sine 50 degree is 0.766. Okay, so you just need to go to that particular angle. If you are doing the straight sine 50, sine 30, sine 50, sine 51, sine 41 degrees. So if you are doing that directly sine the angle, go to that angle, the corresponding next value will be the value of that sine. If you are going the reverse way, sine inverse, then you look this second column first and then you find what is the angle. So angle to value, value to angle. Okay, so this is the value, and this is the more accurate values are there on the right hand side, but more accurate values are not expected. You can skip that out. If it is 40.4, you are writing 40 degrees, you will get full marks, or it is 40.5, you are writing 41 degree, you will get full marks. So don't worry about those small variations. Okay, you just need to concentrate on the first column and correspondingly the value, or the value of the angle and corresponding value of sine and tan. Okay, sine, tan, different tables are there. 3 different tables will be provided: natural sines, natural cos and natural tangent. Now based on your physics, cos is very rarely occur, mostly sine and tangent. You need specially tan for your alternating current problems. Okay, alternating current problems you require tan, and ray optics related problem, if it is a prism related problem you might require sine as well. Cosine is very rare, where you are trying to find the power factor in AC circuit, then you might require cosine, otherwise cosine values are not required. Okay, any doubt? Revanna, I am teaching how to read sine and cosine table. I am teaching you how to read sine and cosine table. If you are solving numerical questions in your board exam, you might need to use sine and cosine table, sine and tangent table. How to read that? Okay, that's what I am teaching. So suppose you are finding tan of 33 degrees. You know tan 30, but tan 33 you do not know. Then how can you calculate tan 33? So you go to the natural tangent table. So look into the headline, here it will be mentioned the natural tangent. Go there and you find the value. On the first column you find the value 33. So this is the 33. So tan 33 is this value. Okay, tan 33 is this value. Suppose you are solving a problem where you need to find tan inverse of 1.7. Tan inverse of 1.7, you again go to the same table and scroll down or find the value where it is closest to 1.7 in the second column. So if you see that closest to 1.7 in the second column is this, so the value will be 60 degrees. Okay, so based on your, either you are doing tan inverse or you are doing tan theta. If you are doing sine inverse or sine theta, so sine theta, obviously sine table you have to go. I'm not scrolling. So sine 56 degree. Sine 56 degree, you go to the second column, that will give you the sine 60 degree in sine table. Tan 56 degree, you go to the second column, this will be your tan 56 degree. This is this. Ignore this dash, it will be dot. Okay, ignore the dash, it will be dot. So 1.4825 will be the value of tan 56 degrees. Similarly, if you are finding tan inverse of 1.8, tan inverse of 1.8 will be 61 degrees. Okay, so based on the question, you need to know how to read the first column and the second column. First column is the angle, second column is the value. Okay, the remaining columns are accurate values. You are not expected to go to that accuracy. It is not like log and anti-log table. Okay, it is simple sine cos table. You can restrict yourself into this first two column. First column gives angles. Okay, this is the angles. So this is angle and this is the value. Okay, so these two columns are only thing that you need to know how to read. Okay, you can go into Jaideep's class. What are you doing over here? If you are interested in Jaideep's class, go there. Why I have not forced you to join in my class, right? You can go and Jaideep's class and you can read from me. Every teacher has their own quality. Okay, I am not saying that I am a very good teacher. Okay, you should learn from me. It is up to you. If you think that okay, I can score 70 out of 70, you can go there. I have track record. I have scored people 70 out of 70 last year. Okay, maybe you are learning from there. Okay, I am not forcing you to join over here and spoil my chat. Okay. Okay, now let's start with the top 200 MCQ as the session promised. So I told during my numerical class that those if you have joined my previous class, you would have know what I was doing. So I told everyone that I will be teaching you how to read sine cos table. I have done it in the past. Again, I am doing it in this class as well. Okay, not many of you have born genius. They require time to understand something. Okay, most of our students are like that only. Okay, so if you are someone who is genius, you can understand anything, then you are not required in this class. I am doing it for all the students. Okay, those who are a little struggling in the MCQs and all the other subjects. Now let's continue. So first, obviously 200 MCQs as promised. 214 MCQs I will be doing in today's lecture. Okay, so now question number 1. Electric field at a distance small r from infinitely long straight uniformly charged wire is inversely proportional to, or most of the questions are taken from question bank only. So those who are saying, sir, please solve question bank, attend this session, all of your question bank related doubts will be covered. Okay, so that is my guarantee. And if MCQs are directly coming from question bank, you will be able to answer them. But remember that questions may not come, but the concept will 100% come. So if you solve these 200 MCQs and understand the intricacies how they are being solved, you will be able to answer all 15 MCQs day after tomorrow. That is my guaranteed. Okay, but you have to be a little patient and you have to watch till the end. If you are in a hurry, then watch as much as possible, then you can go to your bed. But please be patient. It will not take too much of time, 3 to 4 hours. That much time I am asking from you. The electric field at a distance small r from infinitely long straight uniformly charged wire is inversely proportional to r, inversely proportional to cube of r, inversely proportional to square of r, independent of r. Most of you, thank you Yeshan, Sridevi, Bunny, Udupal, everyone answered. Sir, reading according to blueprint will be enough, right sir? Yes, yes, blueprint is good, but blueprint there are some there are some confusion in the blueprint, because especially the numerical and derivation section, they have not given the clarity from which chapter derivations, from which chapter numerical. Okay, but apart from that, yes, blueprint you can study. Next, for example, in the chapter wave optics, someone was asking, sir, in the blueprint there was no 2-3 mark question, but from wave optics chapter 2 plus 3 mark question is very common in 5 mark derivation. So if you study 2-3 marker questions, that will cover up your 5 marker question as well. Okay, so that's why I have given it like that. Which one of the following charges is not possible? Very interesting question. Okay, everyone is saying, to Amulya, Bunny, Sri Devi, everyone is saying option C. Why option C? First of all, let us understand, this is the minimum possible charge of an electron, so this is possible. Any integer multiple of this value is possible. This is you multiply this by 2, you get this value. Okay, you multiply this by 4 and you get this value. But if you multiply with 3.5, you get this value. So this is a not integer multiplication of this value. That means this is not possible. Okay, so understand this. In exam, you might see some different value, but make sure if it is a multiplication of this small charge, then it will be always possible. If it is not integer multiple, it is not possible. Okay, if it is a fraction, it is not possible. Next, the electrostatic force between two charges in vacuum is given by F equals to K Q1 Q2 by R square, where K is easy. Okay, Bunny, but some students do need explanation. So, so if you see that in this question, units are different. Okay, 9 into 10 to the power of 9 we know. Okay, but units are different. So you need to make sure which unit to choose. Okay, which unit to choose, that you have to be careful about. So force is Newton, K Coulomb square divided by meter square. Okay, I am just putting the units. Coulomb, this is Newton, this is meter square. Okay, so you get K's unit is Newton meter square per Coulomb square. So correct unit is Newton meter square per Coulomb square. So that is option A is correct. Okay, option A is correct. Yes. So make sure, so this is also very tricky. You have to make sure that unit you are choosing correctly. If you forget, you should know how to find the unit as well. The direction of electric field vector at a point on the equatorial line of a dipole is. Direction of electric field vector at a point on the equatorial line of a dipole is in the same direction of the dipole moment, in the opposite direction to the dipole moment, towards negative charge, away from the positive charge. So everyone is answering 4B. 4B, in the opposite direction, electric field is in this direction, dipole moment in this direction. So electric field and dipole are opposite direction for on the equatorial line. Next, name the physical quantity which has dimensional formula LT A. Okay, leave travel allowance. Now next, yes, option B was correct. 5C. Yes. 5C, dipole moment. Yes, if you see that T into A is charge, L is distance, so charge into distance, it is a dipole moment. Next, dash placed in an electric field. If you have any doubt, please mention that in the chat. Dash placed in an electric field experiences a force in the direction opposite to that of the electric field. Electron, positive charge, neutron, proton. Yes. Amaya, Purti, Udupal, everyone is correct. This is an electron. This is an electron. Next, when a free electric dipole placed in a non-uniform electric field, the dipole will experience both force and torque. Only force but not torque, only torque but not force, neither torque nor force. Okay, non-uniform electric field, it is placed in a non-uniform electric field, it will be both force and torque. If you have answered anything else, it is wrong. Most of you have answered it correctly, all of you have answered it correctly. Okay, now next question. Electrostatic field lines can never form closed loops. This is due to electrostatic field lines can never form closed loops. This is due to conservation of charges, conservation of momentum, quantization of electric charges, conservative nature of electrostatic field. Let's see who can answer. There are a lot of confusion in this question, and some of you are answering B, some of you are answering D, some of Purti is saying option E, which is not there at all. For question 5, why not B, sir? Okay, let's see. What is question 5? So, what is capacitance? Capacitance equals to epsilon naught A upon D. Okay, what is the unit for epsilon naught? So epsilon naught is equals to 1 by 4 pi epsilon naught. 1 by 4 pi is constant, is unit is Newton meter square per coulomb square. Okay, so this is the dimension of now what is the dimension of epsilon naught? So epsilon naught unit will be coulomb square by Newton meter square. Okay, from this also you can do it, or from other unit you can also do it. I like to do it in this way. So A into T. So if you try to find the dimension, it will be AT square divided by L M L T to the power of minus 2 into L square. So it will be A square T square divided by M L cube T to the power of minus 2. So now you have to put it in this formula. Obviously this is much more complicated. Of capacitance, A square T square divided by M L cube T to the power of minus 2 into M into, sorry, area is L square divided by L. So obviously you see that this is not at all closer to this dimension. Okay, so that's why it is not capacitance. Capacitance is much more complicated than dimension of dipole moment. L square T to the power of minus. So dimension of capacitance is M to the power of minus 1, L to the power of minus 2, A T to the power of 4. So this is the dimension of capacitance. Okay. So make sure that you should not get confused in anything else. The dimension of capacitance is a KCET level question. Now, electrostatic field lines can never form closed loop because of the conservative nature of electrostatic field. So whatever work you do, you get back that work. So that means conservative nature of electrostatic field. That's why electrostatic field lines can never form any closed loop. So our answer is option D, not B, not C. Okay. SI unit of electric flux is, SI unit of electric flux, yes, option D was correct. Out of 10 MCQs, how many are applied, sir? There will be 15 MCQs, not 10. 2 to 3 of them will be HOTS question. That is, you are saying applied, application based. Okay. Remaining you can answer if you memorize or if you have understood. Understand, and so basically they categorize it based on easy question and HOTS question. Easy question, so 12 to 13 will be easy, 2 to 3 will be HOTS. SI unit of electric flux is, so what is the SI unit of electric flux? Who can answer? Electric flux, not magnetic flux. Weber is magnetic flux. Yes, correct. So electric flux is E into area. E is Newton per coulomb, A is meter square. So Newton per coulomb into meter square is the electric flux. Next, electric field intensity at a distance small r from the center of uniformly charged sphere outside the sphere is capital E. Which one of the following is correct? Okay, electric field intensity is nothing but electric field at a distance smaller from the center of uniformly charged sphere. So if the center of the uniformly charged sphere, suppose the charge is q, small q it is given here. So small q is the charge. Now it says that on which factor does it following is correct. Following correct means one is correct, remaining are incorrect. So electric field is given by kq by r square as long as r is greater than radius. For E inside, if it is a conducting sphere, electric field will be 0. For non-conducting sphere, it will be complicated, out of syllabus. Okay. So obviously we see that it is proportional to the charge and inversely proportional to the square of the distance. So correct answer is option C. Yes. Kunal, everyone, Bunny, Raistar, Jia, everyone is correct. Sir, if we read model question paper, all the 2 preparatory question paper for MCQs, will I score all the 10 marks in MCQ? First of all, Sheikh, there is not 10 MCQs, 15 MCQs will come. Model question paper, from model question paper, MCQs generally do not come in the final exam. Conceptually questions do come, okay, but that concept is also generally is not very close, it is little far away. Model question bank, on the other hand, if you practice the question bank, that we are doing today, from question bank you are going to get all the 15 MCQs conceptually. Some cases almost same question with slightly variation comes from the question bank, but not from model question paper. Model question paper is for your preparation. Okay, so if you want to attempt a mock test, how the paper looks like, if you want to practice them, that's why model question papers are there. But exact questions are limited to 30 to 35 marks. Even if the MCQs are coming, that will not beyond the score. So total score you can do from all 3 model papers and practice papers will be limited to 30 to 35 marks. Practice papers are not for you as well. Practice papers are from last year, where it was given for exam 2 and exam 3. This is not for this year. There was no practice paper this year. Practice papers are from last year's exam 2 and exam 3. That is available in their portal, but that is not for you. Not directly for you. You can practice there from there as well. The electric field due to an electric dipole at any point on its axis, which is at a distance small r very very greater than length of dipole from its center, varies according to, okay, electric field due to a dipole at any point on its axis is proportional to 1 upon r cube. Be it on the axis, be it on the equatorial plane, it will always be 1 upon r cube. Now match the following. This is a HOTS question, application question, whatever you say. Okay, this is a question. Those who are thinking how many HOTS questions, this is a HOTS question. Let's see. Some physical quantities are mentioned over here, their units are given over here. You have to match electric field, electric flux, permittivity. Okay, permittivity is unit we have already calculated. Permittivity is given by this. Okay, permittivity is given by this. What is electric field? Here electric field not given in terms of normal unit, it is given in terms of potential. Okay, so electric field in terms of potential is volt per meter, and electric flux is volt per meter into a meter square, that is voltmeter. Okay, how do you know that? Because electric field is given by dV by dx, okay, minus dV by dx. dV means voltage, volt, okay, and x is meters, so volt per meter is also unit of electric field. Okay, this is the potential unit of electric field. So correct match is 1 with B, 1 with B, 2 with C, and 3 with A. Okay, so correct match is option A. Now remember, while doing the match the following question, if you don't know at all, try to match at least 1 or 2. Based on that 1 or 2 matching, you generally will be able to answer the question. Yes, option A is correct. Next, okay, before I going into any further, just wanted to tell you that our special Holi offer is going on for all of our courses. KC30 on offline Lakshya KCET crash course as well as ABHYAS test series. The price for KC30 is 2499, and if you register yourself for Lakshya offline KCET, you will get a early bird of 3000 offer for Holi, as well as if you want to purchase ABHYAS KCET test series, it is available all time low for 999 only. Okay, so now if you want to do anything, you can go into the description section of this video and you can get the link for all these courses. And if you are really interested for your KCET, then you should register yourself through that link, but not now. Maybe tomorrow, maybe after your physics exam is over. Now let us concentrate on this preparation. Statement number 1. Statement based questions are also HOTS question. So if you are wondering what are all the HOTS question, what is the meaning of HOTS question? HOT does not mean hot, it means higher order thinking skill. Higher order thinking skill. So you have to think a little bit higher to answer these. Statement 1. The electric field lines never cross each other. If electric field lines cross each other, field at the point of intersection will not have a unique direction, which is not possible. So if two electric field lines do cross, okay, we know that any tangent drawn at the point will give the direction of electric field. So electric field at this point will have two direction, okay, which is not possible because electric field is a vector quantity. A vector has only one direction, not two direction. Okay, so here the electric field will be confused which direction we have to go. That means this is not possible because this will violate the condition for electric field being a vector. Okay, so both statements are true, and second statement is correct explanation of statement number 1. Sir, will you teach in KC30 batch? Yes, I will be teaching. Sir, is this enough to core out in MCQ? Yes, Prithvi Gowda, yes. Which question bank? Question bank by your board. Yes, Prithvi, I told you this is enough. If you practice all these questions, you will be able to score 15 out of 15. Now exact questions may not come, they might change little bit, but if you have studied this, now the same question comes for magnetic field as well. You know, okay, electric field it's true for magnetic field as well, so you can answer that. Okay, so even if they change the electric to magnetic field, you should be able to answer it. Okay, now next, 4 charges are placed on a corner of a square PQRS as shown in the figure. The direction of the resultant electric field at the intersection of the diagonal is. So here we have 4 charges, +2, +2, +2, -2. What is the net electric field? Direction of the net electric field. You don't need to calculate the net electric field, you just need to find the direction of the net electric field. Okay, so how to find the direction of net electric field? Yes, I will cover all the chapters. I will cover all the chapters. 200 MCQ is not a joke, okay? We will be covering all the chapters. So that means, so first let us understand these 2 point charges. This is positive 2, this is also positive 2. So that means electric field due to positive 2 is in this direction. This is S. Electric field due to this positive 2 is in this direction. This is Q. Now both charges are at equal distance for this because it's a square. Okay, so this distance and this distance are same. So these Q and S should be same and they will cancel each other. So Q and S will cancel each other because both of them are positive. Now what about this positive? Positive due to this will be in this direction, that is P. Now this is negative, this is not positive, this is negative. So electric field due to negative charge is towards. Okay, electric field due to positive charge is always away from. So if there is a positive charge, electric field always point away. If there is a negative charge, electric field always point towards the charge. Okay, here this is a positive charge, so electric field is away. This is a negative charge, so electric field will be towards. So this is the electric field. So now if you see that the net electric field is from O towards R, so it will be towards R. The net electric field will be towards R. So correct answer is option C. Okay, you don't need to do any mathematics, just logical understanding of this is sufficient. Jaideep, you are a teacher, right? You teach in a class. What are you doing over here? Question bank book. Question bank is provided by your state board. Okay, question bank is provided by your state board. It is not any question bank, it is question bank from your state board. Okay, you can download it from student portal. In the student portal there is a question bank of all subjects are available, including physics. Pramath Sundatti. Pramath, I have solved numerical questions from today in the 2 hours. I have solved numerical questions. You can do check that out for your alternating current, right? And if you are asking about any other question, no other question is going to come from alternating current, in only MCQs and maybe fill in the blanks. Okay, 2 questions are there. So 1 MCQ, 1 fill in the blanks. That is what my guess is. No 2-3 marker questions is going to come from alternating current. Only 5 mark numerical. I have done 5 mark numerical in today's session, earlier session. You can go and check that out, or you can download the PDF. PDF is also available. Okay. 14th. So understand this. What is this charge? What is this charge? What is the sign of this charge? This is positive. Where we are finding the electric field? We are finding the electric field at this point O. So what will be the direction of electric field due to this positive charge? Direction of the electric field due to this positive charge, for this positive charge, it will be away from, if you join this point, then if you go away, this will be the direction of electric field. Okay, and what will be the electric field due to this positive charge? The electric field due to this positive charge at this point, you join these 2 points, you extend it in this direction, that will be the direction of the electric field, right? Now what is the magnitude? Magnitude wise electric field is always given by KQ by R square. Right, if you see that this is also +2, this is also +2, so Q is same. Okay, now the distance of this, suppose this is X, this will also be X, so R is also same. So net electric field at this point due to this positive and this positive equal and opposite. So electric field equal and opposite means plus Q minus Q, that will be 0. So net electric field due to these 2 positive charges will be 0 at this point. So they will not have any effect at this point. Okay, they will not have any effect at this point. Now we have to, so these 2 charges are sorted. Next we have to move on to this charge and this charge. Now again, what is this charge? This is positive charge. So net electric field will be in this direction, away from. Okay, because positive charge is always join the line away from. So this is the net electric field due to plus 2 nanocoulomb. What about minus 2 nanocoulomb? Minus 2 nanocoulomb charge minus means net electric field will be towards. Net electric field will be, you join the line, it will be towards that point. Now again, so this is plus 2, this is minus 2, but they are in the same direction. Same direction means it will be added. Okay, electric field is a vector quantity. If they are in the same direction, you can add them. If they are in the opposite direction, they will be subtracted. If they are in any other direction, then you have to use vector method to find the sum. If they are in any other direction, you have to use vector method to find the sum. Here it will be in MCQs question, that kind of difficult question will not be asked. You will be simply need to find, okay, these two charges are same, so net effect of these two charges should not be there at the center. Okay, this is positive, this is negative, so net electric field will be from positive towards negative. That is the easier understanding if you have understood this concept. Okay, so it will be from positive towards negative. But in that will be incorrect if I not explain these two charges. If these two charges are not equal, then it will be a very complicated problem. But if these two are equal charges, then it is a very easy, simple problem. Positive, positive cancels. This is positive, this is negative. So net electric field will be from positive towards negative. Okay. They might ask, Mohi, you don't know. Obviously charge they will change, orientation might be they will change, okay, but yes, they can possibly ask this question. Now let's see this question. The following figure shows electric field around two charges. So here we have two charges. I hope you can see the diagram. Okay, so these are the two charges. What are the nature of these two charges? Okay, let's see. Both charges are positive. Both charges are positive. Both charges are negative. One is positive, one is negative. Now if you see that both charges are actually having the same charge because they are repelling each other. Okay, if one is positive, one is negative, they should go into each other. Now as they are repelling each other, that means they are same polarity. Now all the electric fields are going away. That means both are positive charges. Okay, both are positive charges. If both are negative charges, all field lines would be converging towards the charges. Okay, if you reverse the arrow, it will be negative charges. If it is away from, that will be positive charges. So similar question might come with this different configuration. So make sure you understand the charge configuration. Equal charges are given to two spheres of different radii. The potential will be, so we have two spheres, one is big, one is small. Equal charge is given to both of them. So this is small r, this is capital R. Now we have to find which one will have higher potential, which one will have smaller potential. Let's see. Interesting, very intelligent question. Thank you, Raya. Sir, few doubts. Which chapter 1 or chapter 2 expected numerical? Is it good to do any ray optic or wave optic practice for numericals? Pradyum, one numerical will come from chapter 1 or chapter 2. That is for sure. But which chapter the numerical will come? My gut feeling. But don't blame me if it is I am wrong. Okay, my gut feeling is saying that this year the numerical will be from chapter 2 and derivation will be from chapter 1. That is what my gut feeling is saying. But I am only 60% sure. 40% is a doubt. So 40% chance is that it will be same as last year, where a numerical question will be coming from first chapter and derivation will come from the second chapter. Okay, but my gut feelings says that numerical will come from second chapter, but I cannot recommend you to do that. You have to practice numericals from both chapters. If you have attended my lecture in the evening today, there also I told you the same thing, that I am expecting that numerical will come from the second chapter, but I may be wrong. Okay, so you have to practice numericals from both chapters. So electric potential due to the bigger sphere on the surface. First we have to calculate the electric potential on the surface. Okay, so electric potential on the surface is given by KQ divided by radius, and for this it will be KQ divided by radius. Now as you can see, the radius is bigger, so electric potential due to bigger sphere will be smaller compared to smaller sphere. So electric potential due to smaller sphere will be more. Okay, more on smaller sphere. The potential will be more on the smaller sphere. Option B is correct. Derivation will come from first chapter. As I mentioned, essentially I am expecting that. Okay. Hi Sri Lakshya. I am expecting that, but that can be reversed. Okay, first of all, there are few things that you need to know. There are a lot of technical aspects of there as well. So but I am expecting that because last year back to back two papers, the pattern, first two papers they followed the pattern, second chapter derivation, first chapter numerical, but I am expecting that to break this year. But obviously don't trust me blindly on this. I am also not sure, but I can obviously tell you that first two chapters, one numerical, one derivation will come, but from which chapter, what, even not even the paper setter knows that, because if there are paper setters, there will be multiple paper setters, there will be multiple papers for each exam. Okay, and generally they set 5 different papers. 3 papers are given for your exams. Okay, 2 papers are stored in a safekeeping in case there are some paper leaking happened or some emergency happened, then they give the other 2 papers. Okay, so that is how the exam function. That is a technical thing. So even the exam paper setter does not know which is the paper number 1. Okay, they know that I have submitted a paper. Now whether my paper is selected or not, that also they do not know. There is only one person generally who is the chairman of this exam body. He only knows which paper is going to come in your paper. Okay, so that is how the secrecy is maintained. So paper leakage is almost impossible, and it happens, but it is not like it happens sometimes during the printing, sometimes during the transport, but not from the teacher's end. The dimension of electric polarization is given by dimension of electric polarization. What is polarization? Electric polarization is dipole moment per unit volume. Dipole moment per unit volume. Okay, polarization is defined by total dipole moment per unit volume. Now dipole moments dimension we have already seen, which is LAT. If you remember, dipole moments dimension is LAT. Volume is only L cube. Volume is meter cube, that is its dimension is L cube. So its dimension will be L to the power of minus 2 A into T. L to the power of minus 2 A into T. So correct answer is option A. Okay. Will 3-mark numericals come from dual nature? It might come. It might come. There is a possibility it might come. Okay. It might come from dual nature. It might come from capacitance chapter. Okay. If 5-marker numerical is not coming from that chapter, there is a possibility a 3-marker numerical might come from that chapter or from the first chapter itself. Might be. I'm not sure, but yes, 3-mark numericals generally tend to come from second chapter if it is not being coming as a 5-mark numerical, or from nuclei chapter, and maybe dual nature of radiation chapter. Okay, that is the historical trend. They change it from time to time. 2 mark numerical is generally easier, much easier, just one line, two line answer is there. 3 mark numerical can be tricky, can be little bit calculative. The electric potential at the surface of a charged spherical shell of radius 10 centimeter is 20 volt. The electric potential at the center of the shell is. Answer quickly. Answer quickly. Sony, no, all MCQs will not come, but the concept will come. Okay. If you understand this question, if similar question based on this concept is coming, it is considered to be question from question bank. Okay. But if you are only trying to memorize, it will not be happening like that. The electric potential at the surface of a charged spherical shell of radius 10 centimeter is 20 volt. The electric potential at the center of the shell will be, yes, 20 volt only, because electric potential inside the shell is constant. It is not zero, it is constant. Okay, potential inside a shell, conducting sphere or shell is constant. Potential is constant, electric field is zero. Next, the electric field at a point which is very close to a surface of a charged conductor with the surface charge density sigma is E equals to sigma by 2 epsilon naught, sigma by epsilon naught, 2 sigma naught by epsilon, 2 sigma by epsilon naught. It can come from any chapter. It can come from any chapter, okay? It can come from second chapter, it can come from first chapter, it can come from ray optics chapter as well, it can come from moving charges and magnetism chapter as well. Generally it is very easy. Okay, electromagnetic induction is one chapter from where it came last year. Okay, half Li square was the formula that you need to use. So it can come from any formula related chapter. Obviously magnetism and matter and electromagnetic wave generally do not have any important formulas. So those two chapters you can skip. Otherwise it can come from any chapter. Okay, it will be very easy, very simple. Yes, it is sigma by 2 epsilon naught. Electric field near a charged conductor will be sigma by 2 epsilon naught. Okay. The energy density between the plates of a charged capacitor is given by energy density. Energy density is energy divided by volume. Which is the correct answer? Impact parameter when minimum and maximum. So impact parameter is the distance from the nucleus. Remember, impact parameter is the distance from the nucleus. So if impact parameter when it is going straight towards the nucleus, when it is going straight towards the nucleus, impact parameter is minimum, scattering angle is maximum, 180 degree. Okay, if it is going further away from the nucleus, then angle of deflection is minimum, impact parameter is maximum. So theta, angle of deflection or angle of scattering, and impact parameter, they are inversely proportional. Okay, higher the impact parameter, smaller is the angle of scattering. Okay, smaller the impact parameter, higher is the angle of scattering. Okay, so remember this, angle of scattering and impact parameter, they are inversely related. Higher impact parameter, small scattering, smaller impact parameter, high scattering. Okay, don't confuse this with distance of closest approach. Okay, C, yes, half epsilon naught E square is the energy density. Remember this formula also, this sometimes be asked as a 2-marker question. The potential energy of an electric dipole placed in a uniform electric field is. So we solved it I think yesterday as well. This question, quickly answer this. Potential energy of an electric dipole placed in an uniform electric field. Yes, A. Someone was saying why not B? B is cross product. Cross product gives you a vector quantity first of all. So potential energy is a scalar quantity. Remember that potential energy is a scalar quantity, so it will be dot product, and potential energy is negative. Okay, by nature in electric potential energy is negative, so there is a negative sign as well. So if suppose this option is given P dot E, okay, and this option is given P cross E, okay, then you have to understand that this is not P dot E, it is minus P dot E. Okay, remember that. Next, an electric dipole is placed in a uniform electric field. The dipole moment makes an angle theta with the electric field. For what angle theta is the potential energy of the dipole is maximum? For what angle theta is the dipole moment maximum? Potential energy is maximum. 22D. Amya answered, Distortion also answered, Chinappa answered, Mohi answered, Ganesh, Ushacharya, okay. Stop Amya, I told your name Amya, so why you are repeating? I said you answered D. Okay, so potential energy is given by minus PE cos theta. P dot E, dot product means cos theta. Okay, so minus PE cos theta, so it will be maximum when cos theta is minimum. Okay, it will be maximum when cos theta is minimum. Minimum value of cos theta is not 0 but minus 1 when theta is 180 degrees. Okay, so theta 180 degree will give you U value maximum. Okay, max, that is minus PE into minus 1, that is P into E. Okay, understood? So correct answer is this. 90 degree has no effect, 90 degree is only 0 value. This will be the minimum value. If the same question is asked saying that at what angle that potential energy will be minimum, that will be 0 degree, maximum 180 degree. Stable equilibrium 0 degree, unstable equilibrium 180 degree. Equilibrium can also be asked. Okay, equilibrium means potential energy is maximum but torque is 0. Torque is 0 for these two cases. Torque is 0 for these two cases. So this will give you the unstable equilibrium. This will give you the stable equilibrium. Next, capacitance of a capacitor defined as C equals to Q upon V. A factor on which capacitance of the capacitor depends is charge Q, geometry of the conductor, potential difference V, all of the above. Very interesting question. Who can answer this? Fastest finger first. Okay. Most of you have answered correctly, which is only geometry of the conductor. Capacitance, even though capacitance is given by Q by V, the ratio of Q by V is constant. The ratio of Q by V is constant and that constant is called capacitance. Similar to that of Ohm's law. V equals to IR. Okay, R is equals to V by I. But R itself is a constant for a given conductor. Okay, it depends on length, it depends on area, it depends on the material of the wire, but it does not depend on voltage or current. Similarly, here also capacitance C is a proportionality constant. It does not depend on Q or V. Okay, the ratio of Q and V is constant and that proportionality constant is C. It is dependent only on A epsilon naught by D. That is the expression for capacitance. It does not depend on potential, it does not depend on charge. So it only depends on geometry. Next question. Capacity of a parallel plate capacitor can be increased by increasing the distance between the plates, increasing the thickness of the plates, decreasing the area of the plates, decreasing the distance between the plates. Which one is correct? Yes. Tomorrow, yes Mohi, tomorrow I will be taking live at 5, okay, of 50 most important questions, including all type of questions I will be taking. And Aditi ma'am will be, some students have asked about 2-3 markers and 5 marker derivations, which I did, but not as a separate way. I did it in the yesterday's live. I did all 2-3 5 marker questions. Some students wanted that, sir, we want 2-3 and 5 marker questions individually, so that's why Aditi ma'am will be taking live in the morning tomorrow for 2-3 marker as well as 5 marker derivations. Okay, Those who don't know Aditi ma'am is our physics teacher. She teaches in our class 10th channel. She did some videos in our channel as well. If you want to check that, model paper 2, model paper 3 individually was done by her. I did model paper 1, then I was on leave for few days, so she took model paper 2 and model paper 3. And also she did a lot of live sessions for question bank series when we are doing it. Okay, yes, tomorrow class is there. Tomorrow is also class is there. Live in the morning by Aditi ma'am, evening I will be taking live. Day after tomorrow also there will be a class, don't miss out on that. Very quick 30-minute revision and a 1 hour early morning revision will be there around 6:30 to 7:30. Okay, no discussion there. I will just teach there. Okay, I will take very few comments in the morning session and one recorded session that will go live I think around 4 AM. That will be 30 minutes quick revision. Those who wake up early, they can join that. Capacity of a parallel plate capacitor can be increased by, answer, quick. Option D, decreasing the distance between the plates and increasing the area. So increasing the area is not there. Okay, only decreasing area is there. So decreasing area will decrease the capacitance, increasing the distance will decrease the capacitance. Thickness does not depend, okay, as long as the material inside the plate is same. Okay, decreasing the distance between the plate will increase the capacitance. Next, the potential energy of a capacitor is stored in the dash between the plates of the capacitor. Okay, potential energy of the capacitor stored in the dash between the plates of the capacitor. What is the answer for this? Quickly. Who answered A? Distortion, why you answered A? Potential energy, if you go back to potential energy density is most important quantity, which is given by half epsilon naught E square. So energy density is stored in electric field. So potential energy is actually stored in the form of electric field. Stronger the electric field means more energy is stored. Weaker the electric field means less energy stored. So energy is actually stored in the form of electric field. Okay, so energy is stored in the form of electric field, not magnetic field, not current, not charges. It is stored in the form of electric field. Charge is basically, you can have a lot of charge, but if the electric field is not there, you cannot store so much energy. Okay, for example, a neutral material has a lot of charge in it, but electric field is 0. So energy stored is 0. Only way to store energy is to either you change electric field or you change gravitational field. Gravitational potential energy is basically gravitational field. Okay, clear? Now next, which of the following correctly describes the behavior of polar and non-polar dielectrics in an electric field? This is also a hot question. Both polar and non-polar dielectrics have permanent dipole moments, but only non-polar dielectrics are aligned in the external field. Polar dielectrics align their dipole moments with the external field, while in the case of non-polar dielectrics, a dipole moment is induced in response to the field. Non-polar dielectric align their permanent dipole moment in the external field, while polar dielectrics remain unaffected. Polar and non-polar dielectrics behave identically in the presence of an electric field, showing no difference in polarization. Answer this. Yes. Problem from chapter 1 and chapter 2. Srilaksha, I have solved chapter 1, chapter 2 problem in my earlier live. You missed it. I think I saw you, but I am not sure whether you are there from the beginning. So problems, numerical questions I have solved from chapter 1 as well as chapter 2. Okay, also I am going to solve more numerical questions tomorrow, so do join me there. Okay, tomorrow 5 p.m. will be live, so, and after that I think 5 to 7 I will take live, then you can prepare for your entire day, and then again in the early morning I will do some quick revision, and then you can have your just a quick revision, because sometimes you may not be able to focus on reading, so I will be live, I will be teaching, just focus on that and go to your exam. An electric dipole is placed inside an insulating spherical shell. Pick the wrong statement. Electric dipole is placed inside an insulating spherical shell. Pick the wrong statement. Wrong means 3 are correct, 1 is wrong. Net charge enclosed by the shell is 0. So this is plus, this is minus, so net charge is 0. Net charge Q enclosed is 0. Sphere acts as an equipotential surface. Okay, let's figure that out. Electric flux through the sphere is 0. Electric flux through the sphere is 0 because net charge is 0, so flux is obviously equals to 0. Electric field is not uniform across the surface of the spherical shell. So what about the electric field on the surface of the spherical shell? Will that be uniform or not? So these two are the options that we have. Spheres act as an equipotential surface, yes or no. Electric field is uniform, yes or no. Let's see who can answer this. Suppose electric field on the surface of this is given by E. Electric field is given by, on the surface of this is given by E. Okay, now what is electric field? E dot ds close integration equals to charge enclosed by epsilon naught from Gauss's law, or E into ds. Now this is the spherical surface, so that will be the total surface area. Total surface area 4 pi r square, that will be equals to 0. Now 4 pi r square is not 0, so electric field has to be 0. So electric field on the surface of this sphere, each and every point will be 0. So electric field 0 means what? Electric field 0 means it is constant, it is uniform. Now also we know that electric field is given by minus dV by dx. Okay, so that means electric field is 0, so dV will be 0, so V will be constant. Okay, so it is an equipotential surface. Equipotential surface means V is constant, but electric field is not only uniform, it is equals to 0. Okay, electric field is not only uniform, it is equals to 0. So correct wrong answer is option D. Correct wrong answer is option D. This is also a hot question. This is also a hot question. Be careful, be mindful while answering such question. Electric dipole inside a sphere, it is equipotential surface, net flux 0, electric field is 0, okay, and electric flux is also 0. Now next, the following graph shows the variations of two physical quantities with distance small r from the center of a uniformly charged spherical shell. Identify the graph. So graph 1, graph 2. First graph shows the variation of electric field versus distance. Second graph shows voltage versus potential versus distance. First graph shows the variation of voltage versus distance, and second graph shows E versus R. Both graphs shows variation of V versus R, both graphs shows E versus R. Obviously these two options are not correct. You have to find option A or option B. Sir, sorry for late attendance. Master Muttu, yes, you asked me to solve wave optics question. I will solve that, but you have to stay till the end. Okay, so question number option G is saying option A. G, make sure you have understood the graph. This is a, what is the meaning of this point? This point means it is constant. Okay, and this graph means it is 0. Okay, so electric field is 0 inside the sphere. This is the radius of the sphere. Okay, electric field inside the conductor is 0. Electric potential inside the conductor is constant. So this is voltage or potential versus distance, this is electric field versus distance. Okay, so first graph shows V versus R and second graph shows E versus R. So option B is correct, not option A. So V is constant. This straight graph, so if you just see a graph like this, that means it's a graph which is parallel to x-axis, which represents constant value. Okay, so here only V can be constant, E is 0 inside the sphere. So this graph represents inside the sphere it is 0. So inside the sphere electric field is 0. Inside the sphere electric potential is constant. Okay. One thing should have been mentioned over here, R represents the radius of the sphere. Another horse question. Okay. The electric field inside the conductor is 0. All the charges reside only on the surface of the conductor. Both statements are correct. Statement 2 is correct explanation of statement 1. Both statement correct, not explanation. 1 is correct, 2 is wrong, 1 is wrong and 2 is correct. Let's see which one is it. So give guaranteed numerical 5 marks. Shusha Gowda, it is not possible to give guaranteed numericals. Option A is correct. Guaranteed numericals is like, sir, give me a medicine which will prevent me from any future disease. Okay, if you ask me, sir, you go to a doctor and say that, sir, doctor sir, give me a medicine which will prevent me from any kind of disease in future. Is it possible? Okay, even if you take a vaccine, you might get that fever, but that will not that severe. So I can give you vaccine. Okay, vaccine will reduce the effect. If you have practiced those vaccine questions, then you will be able to tolerate the difficult questions and you will be able to solve it. That I did in my previous class, okay, from 4 to 6. 4 to 6, not only 6, it was almost till 7. Okay, sure shot numerical, no one can give. If they are saying that I am giving you, either they have some connection with the board which is illegal, or they are lying. Okay, sure shot numerical no one can give. I can give you sure shot 5 marker question, sure shot not sure shot, I have to give you at least 10 to 15 questions. From there you will get 3 questions definitely. 2-3 marker question also can be predicted out of some group of question. I gave you in the fixed question. You can check that out already. That video is very popular. Now this is a very interesting question. An imaginary sphere of radius r is drawn around a point charge q. Keeping charge q at its center, the work required to move a test charge small q from point A to B is, what is the work done? Numerical fixed chapter I already mentioned, Suhash. I told you that there are electric charges and field and electric potential. From these 2 chapters you are going to get 1 numerical. Current electricity you are going to get 1 numerical. Okay, alternating current you are going to get 1 numerical. Ray optics or wave optics you are going to get 1 numerical. Now my expectation is that ray optics you are going to get the numerical. Wave optics chance is very small. 20% chance is there will be wave optics related numerical. 80% chances it will be from ray optics. Okay. Numerical fixed chapters I told you in if you go and check my last live from 4 to 6 I took it, 4 to 7 I took it. There I have mentioned which chapters are important, okay, for numericals. But also I told you now as well. So what is the answer for this? Yes. Option B, 0. Why 0? Because this is an equipotential surface. This is a point charge, so this is a sphere. So this will be a equipotential surface. Work done to move a charge on the equipotential surface is 0. In the absence of an electric field, the mean velocity of free electrons in a conductor at absolute temperature capital T is 0, independent of T, proportional to T, proportional to T square. Okay. Who can answer this? Hi Ganesh Patil, 31A. Yes. So remember that mean velocity in the conductor at some temperature capital T, electrons are randomly moving. Sum of all random motion, that is mean of random motion, is always 0. This is always true, okay, because electrons are not moving any particular direction. Average motion is 0. Okay, hi Sufyan. Yes, A is correct. Thermal velocity is there, but average of the thermal velocity will be 0. Average, mean means average, okay, mean means average velocity will be 0. Ohm's law is valid when the temperature of the conductor is very low, very high, constant, varying. Easy question. Sir, if I watch top 20 numericals, can I score 10 out of 10? Ganesh Patil, if you watch top 20 numericals and understand what I was teaching there, yes, you can. Okay, concepts are important for numericals, not the exact problem. Exact problem will not come, but obviously those formulas I have used there, the concept that I have used there, how I have solved it, that will definitely help you. Okay, option C, Ohm's law is valid when temperature is constant. In the equation AB equals to C, very common. A is current density, C is the electric field, then B is, why so less V's? Less V's means C is resistance, not resistance. What I am doing? Understand it, it is not resistance. Krish, not wrong answer. Distortion is correct. Mansi is also correct. MP Mylar, no, not B. So understand this. So this is very common question. I am solving this MCQ like 10 times now. So we know that alternate form of Ohm's law, J equals to sigma E. Okay, J equals to sigma E. Now here it is mentioned A is current density. Okay, C is electric field. Okay, A is current density, C is electric field. So A equals to sigma C. So now see that here A is not equals to BC. Here A equals to sigma C. That means we have to isolate this C. So A upon sigma equals to C. So 1 upon sigma into A equals to C. That means this is our B. Okay, so B is actually equals to 1 upon sigma. If you compare these two equations, you will see that C is on our right hand side, AB is on our left hand side. A we have, but what is B then? Then this must be our B. So B is equals to 1 upon sigma. 1 upon sigma is called resistivity, rho. It is called resistivity, rho, not resistance, not conductivity. Okay, it will be resistivity. Understood? Sir, how can pass easily in physics? Sir, tell please. Sufyan Pathan, go check my passing package. 2-hour video, you watch that, you will pass. 2 hour only. I am not asking you to watch 20 hours, 12 hours, 2-hour video is there. Okay, watch that video, understand a little bit about that, okay, how to write the answers about this. You will definitely pass. No compromise on that. Okay. The relaxation time in conductors. Okay, relaxation time in conductors increases with the increase of temperature, decreases with the increase in temperature, is independent of the temperature, changes at 400 Kelvin and above. Okay, the relaxation time in conductor is decreases with the increase in temperature. Relaxation time is inversely proportional with the temperature. Higher the temperature, smaller is the relaxation time. Smaller the temperature, higher is the relaxation time. So you can assume temperature is like your exam, okay, and relaxation time is your play time. So farther away the exam, you are relaxing, okay, relaxation time, you have a high relaxation time. But when the exam is coming, the day after tomorrow is your exam, we have to study hard, we have to complete all the lectures. So that's what relaxation time represents. Next, with increase in temperature, the conductivity of semiconductor increases and metals decreases, metals increases and semiconductor decreases, both metals and semiconductor increases, both metal and semiconductor decreases. Metal and semiconductor are opposite, so these two are not correct. With increase in temperature, so if you increase the temperature, metal becomes bad conductor, a semiconductor becomes good conductor. That means conductivity is a measure of how good a conductor is. Okay, now if this question is asked in terms of resistivity, whatever answer we are selecting for this question, if the same question is asked for resistivity, answer will be exactly opposite. You remember that. Okay, one small change can completely change the answer. So increase with temperature, conductivity of semiconductor increases, metals decreases. With the increase in temperature, resistivity of semiconductor decreases and conductor increases. Okay, so remember that. Okay, next question. Drift velocity of electrons. Drift velocity of electrons is due to motion of conduction electrons due to random collisions, motion of conduction electrons due to electric field E, repulsion to the conduction electrons due to inner electrons of ions, collision of conduction electrons with each other. So drift velocity of electrons is due to which of the following? Yes. Sridevi, Amya, Dragon is here. Shruth is asking, sir, MCQ which are we doing? Is it 90% sure that these will only come, sir? So as I mentioned, exact MCQ may not be coming, but yes, they will change the language, they will change something in there and they will give you the MCQ. So for example, if the question comes that the motion of conduction electrons due to electric field is called relaxation time, resistivity, conductivity, drift velocity, you need to choose drift velocity. So they might change the subject and object. Okay, but yes, the concept, whatever concept is there, we are almost covering almost all the concepts. Yes, so definitely yes. But yes, if you are asking me, sir, I want exact copy of this question, no. Then answer is no. The resistivity of a metal wire increases with the length of the wire, decreases with the area of the cross section, decreases with the length of the length and increases with the cross section of the wire, increases with the temperature. Answer this. Who can answer this? Mention the question number and then answer it. Okay. Yusuf is saying, how do you know this answer? Sir, in current electricity, which derivations are 100% important? So current electricity, in my passing package, I have done three derivations you need to practice: cells in series, cells in parallel, and Kirchhoff, using Kirchhoff's law, Wheatstone bridge. Okay, these three derivations. Sudama is saying 37A, Dragon is saying C, Yusuf is saying C, Krish is saying C, Suhena is saying C, Sridevi is saying C, and remaining all of you are saying D. Okay. Prithvi is as usual saying some other option. He was answering E, now he is saying F. So resistivity is a constant for a given metal. Resistivity does not change with length, it does not change with area, okay, or length or area. If this same question with resistance, then option C could have been correct. Okay, if actually opposite, increases with the length and decreases with the cross section. So if the question was resistance, but here it is calling resistivity. Resistivity depends only on two things: material of the wire and temperature. Remember this will also might come as a 2-marker question in your exam. Okay, mention 2 factors on which resistivity depends. Resistivity depends only on material and temperature. Okay, it does not depend on length, it does not depend on area. So it increases with the temperature. So resistivity increases with the temperature. Sir, if we it do not depend on anything except nature. Yes, flute, correct. Mic volume is less. I see mic volume is full. Okay, let me check. So here, yes, mic volume is full. You check your hello, if we perfect in question bank, can we out of out? Yes, you can. Yes, Shuhas, if you practice all those questions in the fixed question, definitely you can score even out of out with little help from MCQs. Okay, MCQs and numericals, if you solve, you can score out of out as well. 60 plus, obviously you will score. Now, next question. Okay, thank you. So, if you are feeling that my mic volume is low, check your mobile or device volume, that might be low. Okay, increase that. In laptop, if you are watching laptop, there is a separate key button for volume increase. You can use that to increase the volume. Small and identical cells of each EMF capital E and internal resistance small r are connected in series. An external resistance capital R is connected in series. With this combination, the current through capital R is. So here we have small n number of cells in series. Okay, and we are connected that to across a resistance capital R. Okay, so this is E small r, E small r, E small r. Okay, like that we have n number of such cells. So what is the equivalent EMF? Equivalent EMF will be E plus E plus E plus dot 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 up to n, right? So 1 plus 2 plus 3 plus 4 plus 5 plus dot dot dot, you will get NE. Okay, sum of the numbers, sum of series. Okay, so it will be n into E when all the numbers are same, right? Now what? What is the equivalent resistance of the cell? Equivalent resistance will be N into R. Similarly, so what is the current? Current in the cell is given by equivalent EMF divided by the external resistance plus the equivalent internal resistance. These are the internal resistances, right? So N into E divided by R plus N into R. Okay, so it will be NE by R plus NR. Dragon is saying, I understand that the same question will not come, but still we could be able to solve the MCQs of the annual exam of physics. Yes, of course, that is my point. Distortion is saying, sir, resistivity depends on presence of impurities, right? Yes, yes. For semiconductor, it depends. For metals, even if you mix multiple things, multiple conductors together, the average, you get an average conductivity. Okay, for alloys, especially alloys, for example, steel is not as good conductor as copper. Okay, so that is one thing. So if you are considering alloys, generally that alloy part, some of the alloys, they have a constant resistivity. For example, manganese, nichrome. Okay, so they have a constant resistivity. Sufyan, these are for state. We do not do any CBSE in our channel except for KCET exam. KCET exam is common for CBSE state board and ISC board. Okay, otherwise everything is for your state board. What would be the answer if question 38 it was connected in parallel? Which, okay, So if the question, in the same question, if it is connected in parallel, what will be the equivalent EMF? If all the cells are connected, if all the cells have same EMF, okay, I will teach you a trick. If all the cells are connected in parallel, okay, and they all have same EMF, then the equivalent EMF will be same as one cell. Okay, equivalent EMF will be same as one cell. You don't need to do too much mathematics. Just this is a trick. Okay, remember this. If all the cells have same EMF and if they are connected in parallel, the equivalent EMF will be same as one cell. Equivalent resistance you need to calculate. Equivalent resistance will be one cell's resistance divided by number of cells in parallel, and then you can use the same formula. EMF divided by total resistance. Okay, clear? And I guess in that case the correct answer will be this one. Correct answer will be this one. Okay. You can use cell formula parallel, okay, but you will get this. So this is a trick. If you remember this trick, you don't need to waste too much time. Okay, the E1 plus N2 plus divided by R1 plus R2. You don't need to do that. Okay, when all the cells are connected in parallel, the equivalent EMF will be equals to one single cell only. Okay. Very interesting question. Thank you for bringing this question. Yes, that might come. Very well might come. Okay, because this question is from your question bank, and they will change series to parallel and they will say now answer it. Okay, so in that case answer will be this one. Okay, you put that, you will see that. Okay, the current for parallel will be E divided by R plus R by N. So you multiply N, you will get NE divided by NR plus small r. Okay, this is the parallel combination. Okay. Yusuf, the live class I am planning to take till 12. Okay, I will take a little bit dinner break around 10. Then I will continue for further more. Okay, 200 questions we have to complete. If that, and you don't have exam tomorrow, so there is no hurry. So let's finish this once and for all. All of your MCQs will be done today, right? If the terminals, so after this lecture you should be confident that okay, I have attended the lecture, all the MCQs that is coming in the exam I will be able to answer it. If you are attending, and obviously if you have any doubts like that, ask me. Okay, this is very good question. For example, this is a very good question. Okay, and if the question is coming in the exam, you might be confused and that will take a longer time. Now I told you the shortcut that when all the cells are connected in parallel, equivalent EMF is equals to U. Now you don't need to worry too much. You know that okay, this is the case, I know how to solve it. If the terminals of a cell are connected to an external resistance, then the potential difference across the terminal is more than EMF of the cell, less than EMF of the cell, equal to EMF of the cell, equal to potential drop across its internal resistance. Yes, till 12 p.m. Not 12 p.m. sorry, 12 a.m. 12 a.m. my mistake. 12 a.m. Okay, so when the cell is connected to an external resistance, the terminal potential is always less than the EMF of the cell. Remember this. When there is a current in the circuit, whenever there is a current in the circuit, the terminal potential is always less than the EMF of the cell. Terminal potential in fact is given by EMF of the cell minus current in the circuit into the internal resistance. Because of this internal resistance, it will reduce the effect of the cell. Okay, that is why always remember the terminal potential is always less than EMF unless it is completely open, if no current is flowing, terminal voltage and the EMF will be same. Okay, and if it is connected in an external resistance, that means current is flowing in the circuit, and if current is flowing in the circuit, it is always less than the EMF of the cell. So option B is correct. Okay. Suhena, you need to wait till the lecture is over. Once the lecture is over, it will be uploaded in our drive. You can download it from there. And please, 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 I have seen some of the students, they are deleting it. Don't delete, or do not just cut paste it. Okay, anyway, some of you are asking for permission request. You can download it. First of all, you can download it, you can copy it to your own drive. Okay, you don't need editing permission in our drive to for the files. Okay, you can either copy it to your own drive, or you can download it to your PC or laptop or mobile phone, wherever you want. Okay, do not come to our drive and delete it. It creates a lot of issue, because one student will do this and it will hamper other 99 students. Okay, Kirchhoff's first law, that is sum of I equals to 0 at a junction, also called junction rule or KCL, deals with the conservation of. Sufyan Pathan, from 200 MCQs, 15 MCQ will come. Not exactly, but yes, in one form or other, 15 MCQs will come, definitely. It is called conservation of, so this is current, so conservation of charge. Kirchhoff's current law is based on conservation of charge, okay, and Kirchhoff's junction rule is based on conservation of energy. Okay, now in the exam, suppose you are getting a question based on Kirchhoff's junction rule, then you should remember that junction rule is charge. If they ask you Kirchhoff's loop rule, Kirchhoff's loop rule is based on conservation of energy. Okay, if in the experiment of Wheatstone bridge, the position of the cell and galvanometer are interchanged, then the balance point will. So in the Wheatstone bridge, generally this is how galvanometer and battery are connected, right? Now if you interchange the galvanometer and battery, so instead of the galvanometer you put the battery over there, and instead of the cell you put the galvanometer over here. So what will happen to the balanced condition? Okay, so what will happen to the balanced condition? Will it remain same? Will it change? Yes, it will remain same. Okay, even if you change it, the P by Q equals to R by S. This was the original condition, P by Q equals to R by S. Now in this case, because galvanometer is situated like this, you can redraw this diagram. How you can redraw this? You can take the battery like this, okay, because it's just a diagram. Okay, remember, this is just a diagram, and this galvanometer can be drawn. Either you draw it from outside or you draw it from inside. Same point, right? This is basically connecting these 2 points. Either you go from outside or you go from inside. Okay, now the condition will be P by R will be equals to Q by S. Or you can cross this, exchange this, you get P by Q equals to R by S. So same condition is there. Okay, so condition of balance does not change by interchanging galvanometer and cell. Okay, now this is 1, 2, 3, 4. Okay, column 1 gives certain physical terms associated with flow of current through a metallic conductor. Column 2 gives some mathematical relation involving electrical quantities. Match column 1 and column 2 with the appropriate relation. This is a HOTS question again. Okay, relaxation time, drift velocity, current density, electrical resistivity. Now many of you may not know how to find this at all. Okay, but you have to remember some of the quantities. For example, drift velocity, current density, they are common. These are the common terms. Okay, relaxation time can be tricky. Okay, electrical resistivity can be tricky, but drift velocity, current density, they are easy. Okay. Now what is electric current in terms of drift velocity? Electric current in terms of drift velocity is NEA VD. Okay, this is a very common equation. I equals to NEA VD. So I by A equals to NE VD. Okay, this is called current divided by area is called current density J. This is current density J. So that means current density is given by this equation. Okay, current density is given by this relation. Now also we know one more thing, that E by J, let's figure this out, because this is coming from alternating Ohm's law, J equals to sigma E. Okay, so either based on left hand side or right hand side you need to figure it out. So J by E equals to sigma, but here we have E by J, so E by J must be equals to 1 by sigma, and 1 by sigma I told you is resistivity, so this must be resistivity. This must be electrical resistivity. Okay, now drift velocity in terms of relaxation time is given by E tau divided by m, and relaxation time, even if you don't know, you can match the last two. Okay, so this is how you should match. Remember, relaxation time does not have any time in it, so relaxation time should match with this and drift velocity should match with this. So 1 is matching with C, 1 is matching with C, 2 is matching with D. Next, current density is A, and electrical resistivity is B. Now always I tell you that if you are not able to solve the entire match the following table, then how to answer? If you are not able to match the following table, at least try to match 1 or 2. Make sure that you know that. Do not guess for 1 or 2 correct match. Okay, once you are sure these two are correct match, then you go into the option and find that if that match is unique or not. For example, in our match the following, current density was perfectly matched with 3, so 3 matching with A. If you are lucky, you might find one unique match, so only one matching current density matches with A. So if you are sure that this is perfect, then that will give you the correct answer. You don't need to check any other matching. That will automatically be correct, because other matching for this one is wrong, right? So matching of this one single quantity with A, you can answer this entire match the following. Okay, so these are the tricks. Yusuf, my name is Shaumik. Okay, you can call me Shaumik sir. If you are following our lectures at PDF, Suhana, I will give you after the lecture is over. Okay, statement 1, when a wire is not connected to battery, then no current flows. Statement 2, in the absence of electric field, free electrons move randomly or does not move in a particular direction. Both statements are true, and 2 is correct explanation. Both statements are true, but statement 2 is not correct explanation. 1 is true, 2 is false. 1 and 2 both are false. MD Mario distortion ABHYAS transformer NS by NP is equal to 100. Just a second. This means that the output current is 100 times B. The transformer is step down. Transformer is, the output power is 100 times. The input current is 100 times. Okay, I will answer it. Just a second. So correct answer for this question is option A. So number of primary by number of secondary is 100. Okay, so that means voltage of primary divided by voltage of secondary is 100. So this is a step up transformer, step down transformer, sorry. Okay, number of primary is more than secondary, that means it's a step down transformer. Okay, so voltage of the primary is greater than voltage of secondary. Okay, current of primary is less than that of secondary. Okay, power is constant. For ideal transformer, power is constant. Okay, so remember these facts. So if NP is greater than NS, then it's a step down transformer. If NS is greater than NP, then it's a step up transformer. Okay, so here NP by NS is 100, which is obviously greater than 1. That means NP is greater than NS. So this is a step up transformer. Input voltage is more than output voltage. Input current is less than output current. Okay, so from the given option it will be output current is, output transformer is a step down transformer. So this is a step down transformer is correct. Option B will be correct. Okay, Amaya, got it? What happened, flute? Why are you crying? Which of the following is different from others? Which of the following is different from others? Volt square ohm inverse, ampere square ohm, ampere, volt ampere, joules per second. Now if I am the paper setter, how I will change this question? I will give this as joules per second. Let me change this question, okay, and make it ampere square. Now tell the answer. Same question. Now answer it. Now answer. I changed the question. The question is different now. Okay, question is different now. Flute, check the question now and answer it. D is not correct. Suvarna is answering, distortion is answering, MD Imran, Mohammad Imran also answered. But let's see why something is wrong, why something is correct. First of all, what is volt square per ohm? Volt square per ohm means volt square divided by resistance. What does it represent? It represents electrical power. It represents electrical power. Ampere square ohm means I square R. Okay, so instead of giving into the formula, units are given. This is also electrical power. It is also electrical power. Volt ampere square is VI square. Now VI square does not have any physical quantity. It does not represent any physical quantity. Joules per second. Joule per second is work done by time. Work done by time is also power. So all A, B and D, they represents power. Electrical power or mechanical power, but they all represents power. Their units are same. So this is what, this is what, this is also what. This is not what. Okay, this is a different unit. This is incorrect. For this particular question, this is incorrect. Now remember, V into I, Vodafone Idea. Vodafone Idea is also power. Vodafone Idea is also power. Now this question particularly does not make any sense. You will see that volt ampere, that means they must be related. Joule second, this is completely different unit, so this must be unrelated. Okay, so if this is not given, it is very easy to guess that joule second should be the wrong answer. But when the units are rearranged slightly, it will be very tricky for you to answer, because these units and these units, all three are same units. This is also what, this is also what, this is also what, this is not what. Okay, not energy, power. Yes, yes. Yes, D is the correct for original question. A wire has non-uniform cross-sectional area as shown in the figure. A steady current I flows through it. Which one of the following statement is correct? The drift speed of electron is constant. Drift speed of electron increases while moving from A to B. Drift speed of electron decreases while moving from A to B. The drift speed of electron varies randomly. Okay, drift speed cannot vary randomly, and drift speed is not constant if cross-sectional area is changing. Okay, now what is the relationship between cross-sectional area, that is this area, say this is A, this area say B, say drift velocity here is VA, drift velocity here say VB. Okay. Now equation of continuity, if you remember in the first PUC, you have learned, those you who don't remember, area into speed is constant. Same equation of continuity, that was for liquid or fluid. Same equation of continuity is valid for drift speed as well. So area A into drift speed VA, that should be equals to area B into drift speed B. Okay, or VA by VB equals to B by A. Now which one is greater? B is greater than A. B, so in the diagram you can see the area of B is much higher than area of A. So that means VA by VB must be greater than 1. So that means VA must be greater than VB. Okay, so VA must be greater than VB. So drift speed of electron is decreasing. Drift speed is more over here. Suppose here it is 10, here it will be 8. So drift speed is decreasing as it is moving from A to B. So drift speed of electron decreases while it moving from A to B. Okay, so correct answer is option C. Yes. Yes, this question is all, most of the questions are from model question paper only, Jia. Okay, today we are solving all model paper. Now let us increase the pace a little bit. When a magnetic compass needle is carried nearly to a straight wire carrying current, then the straight wire cause a noticeable deflection in the compass needle. The alignment of the needle is tangential to an imaginary circle with straight wire, as the center has a plane perpendicular to the wire. 1 is correct, 2 is correct, both 1 and 2 are correct, neither 1 nor 2 is correct. So let us understand, straight wire cause noticeable deflection of compass needle. So here we have a compass needle. So if you keep a compass needle near a current carrying wire, the needle will be deflected. Okay, the alignment of the needle is tangential to an imaginary circle with the straight wire, as its center has a plane perpendicular to the wire. So if you consider the alignment north south, suppose this is north, this is south, the alignment is along a circle, okay, with the center is on the wire itself. Okay, so and it is in a tangential direction. So which is correct? Quickly, I will take comments later on. Let me So when a current carrying wire is there, there will be magnetic field associated with the wire, and if there is a magnetic field associated with the wire, then the compass needle will deflect, okay, according to right hand rule. Okay, if the current is being flowing in this direction, the north pole will deflect in the direction of the thumb. So if you just keep a random magnetic needle and if you allow some current to pass, it will deflect, and the magnetic field lines are always circular. So after the deflection, it will align itself such a way it aligns along the tangential direction. So both statements are correct. Both statements are correct. Okay, option C is correct. Yes, Dragon Ming is correct. MD Imran is correct. Flute Soul, Jia, everyone is correct. Someone answered D. D is incorrect. if a current I is flowing in a straight wire parallel to positive x-axis and magnetic field is there along the positive y-axis, then the wire experiences a force in the negative x direction, the wire experiences a force in the negative y direction, the wire experiences a force in the negative z direction, wire experiences a force in the positive z direction. Let us understand. So we have a current carrying wire I, okay, parallel to positive x-axis. So this is positive x-axis, okay, and magnetic field is there along the y-axis. Magnetic field is there along the y-axis, okay. So let's say the y-axis is this one. Y-axis is this one. Okay, what will be the z-axis? Z-axis will be out of the paper. Z-axis will be out of the paper. This is a three-dimensional diagram. This is a three-dimensional diagram. Now, how to find the direction of force acting on the wire? You have to use right hand rule. You have to use Fleming's right hand rule. Okay. So this is the direction of current, this is the magnetic field, then the direction of force will be along the right hand thumb. Okay, right hand rule, yes. So right hand rule, left hand rule is for, no, sorry, left hand rule. You have to use the left hand rule. Okay, so it will be along the negative x direction. Okay, negative z direction. So direction of current, magnetic field, this will be the direction of force. Three vectors. Okay, so this is the current, this is magnetic field, then the force will be along the negative z direction. The force, direction of force into the page of the paper, which is actually minus z. So then this is plus z. So the direction of force is negative z. Option C is correct. Positive right hand is motor rule and left hand is motor rule, right hand is generator rule. Okay, right hand rule is for generators, right? Why are you sending emotes? Stop doing that. Okay, focus on the questions. A strong magnetic field is applied on a stationary electron. I will give you a break at 10. Okay, I will give you a break at 10. Try to complete 10 more MCQs by then. A strong magnetic field is applied on a stationary electron. Then the electron moves in the direction, remains stationary, moves perpendicular, moves opposite to the direction of the field. Who can answer? Which one, Ameya? Last one. Left hand rule, Fleming's left hand rule. You studied in class 10th. Okay, this is the direction of current. Your index finger pointing in the direction of current. Okay, your middle finger points in the direction of magnetic field. Then your thumb will point the direction of the force. So now, how to sometimes you confuse between x, y, z axis as well. So I will tell you that as well. So this is x axis. This is y axis given in the question. This is already you are familiar, right? X in right hand side, y in upward side. How to find z axis? So x cross y gives you z. X cross y gives you z. Remember that x cross y gives you z. So z axis originally is along this. This is the positive z. So into the page will be negative z. Okay, and from Fleming's left hand rule we see that this is into the page. So into the page means it must be negative z. Okay, so remember these things. X, Y, Z is always follow right hand rule for X, Y, Z. X cross Y gives you Z. Now in your throughout your life you will see different configuration of X, Y, Z. Okay, sometimes X will be in this direction, Z will be upward direction, Y will be inward direction. So you will see different configuration. Okay, because if you study engineering, all subjects will have their own Cartesian geometry. Okay. Yes, C is the correct answer. You can answer using bill also. Bill is basically cross product rule. Cross product rule is this. Okay. It is IL cross B. IL cross B, not B cross L. I into L cross B. IL is the current element and cross B. Okay, so it is I cross B. So you can use I cross B as well. L cross B, sorry. A strong magnetic field is applied on a stationary electron. Then the electron moves in the direction of the field, remains stationary, moves perpendicular to the direction of the field, moves opposite to the direction of the field. Okay. You are saying option D. Let me see. Okay, let me just give me a second. Okay, I made a mistake. So this one is current, this one is current. Okay, this one is magnetic field, this one will be your force. Yes, you are correct. Okay, so this one is magnetic field, this one is current. Okay, so current is in this direction and magnetic field is in upward direction, so this will be the force. Okay, yes, correct. So according to Fleming's rule, left hand rule, I was doing this, actually it will be this. So this will be your current, this will be your magnetic field. Okay, index finger will be current, index finger will be magnetic field, this one will be your current, and then this will be your force. Okay, yes, option D is correct. Now next question, 48. You don't need to use right hand rule, you can use left hand rule. Left hand rule I was using wrong. Okay, you can use this current, force, current, magnetic field, current, this will be your force. Okay, force, the left hand rule is the motor rule. Here it is a motor. Okay, basically force acting on a current carrying wire is motor, and a rotating coil generating electricity is generator rule. Generator rule is right hand rule, Fleming's right hand rule. A strong magnetic field is applied on a stationary electron, then it will, what will happen? It will remain stationary. Okay, let me finish a little bit, increase the speed a little bit. Okay, keep up with me. I will not take any comment right now. Strong magnetic field is applied on a stationary electron, then the electron remains stationary. V0, force is 0. Okay, force is QVB. So stationary electron means V0, force is 0. This is Lorentz force. If you are wondering what force is this, sir, this is called Lorentz force. Next, the frequency of rotation of the charged particle in a uniform magnetic field is independent of, frequency of rotation is given by 2 pi omega, which is 2 pi m by QB. So it depends on mass, depends on charge, depends on magnetic field, but it does not depend on velocity of the particle. So if you see the frequency of rotation in a magnetic field, when an electron is rotating in an electric field, okay, the frequency is given by 2 pi m by QB. Okay, and it is independent of the velocity of the particle. Next, the radius of the circle described by a charged particle moving perpendicular to uniform magnetic field depends on. So radius of a particle rotating in a magnetic field is given by R equals to mv by QB. Okay, it is given by mv by QB. So it depends on mass, it depends on velocity, it depends on both mass and velocity. Okay, it depends on both mass as well as velocity. Okay, so it will be C. Next, A long straight wire carrying current induced magnetic induction at any place that is proportional to distance from the wire, independent of the distance, inversely proportional to the distance from the wire, inversely proportional to the square of the distance from the wire. So long straight wire carrying current induced magnetic induction at any place. So magnetic induction means magnetic field, okay, that is produced by current carrying wire is given by mu naught by 2 pi I by r, okay. R is the radius distance, okay. So it is proportional to the distance, inversely proportional to the distance of the wire. It is, so magnetic field is inversely proportional to the distance, not inversely proportional to the square of the distance, okay. Long straight wire, for straight wire 1 by r, okay. Biot-Savart's law tells 1 by r square, yes, but this actually easier to derive from Ampere-Circuital law, okay. Ampere-Circuital law you can do this derivation easily. If it is a curved wire, actually Biot-Savart law says it is 1 upon r square. So if you are using Biot-Savart's law, you might answer it wrong. For a straight current carrying wire, it will be 1 upon r. You have to do the derivation using Biot-Savart's law. It is easier for you to use Ampere-Circuital law. An electron is projected with uniform velocity along the axis of a current carrying long solenoid. Which of the following is true? The electron will be accelerated along the axis. The electron path will be circular about the axis. The electron will experience a force at 45 degree to the axis and hence execute helical path. The electron will continue to move in the uniform velocity along the axis of the solenoid. Okay, electron. So this is a current carrying solenoid, okay. Electron is projected along the axis. Electron is projected along the axis. So what will happen? The magnetic field inside the solenoid is like this. It is almost constant. Inside the solenoid, magnetic field is constant and the velocity's direction is same. So magnetic force will be QVB sine theta. Theta equals to 0. So force equals to 0. Okay. So it will move with a constant velocity, okay. The electron will continue to move with uniform velocity along the axis of the solenoid, because if it is projected perpendicularly, it will rotate in a circular motion, okay. If it is projected along the axis, it will continue to move, okay. Option D, yes. You should not option A, option D. Yes, option D is correct. 2 more questions, then I will give you a 25 minutes break. If the beams of electrons and protons move parallel to each other in the same direction, then they attract each other, repel each other, no relation, neither attracts nor repel. Beams of electrons and protons move parallel to each other in the same direction. The electron is moving in this direction and protons are also moving in the same direction. Then what will be the force between them? If electron and proton are moving in the same direction, remember that proton will give rise to a current in this direction, then electron will give rise to a current in the opposite direction. A beam of electron moving in a particular direction can give rise to a current, okay. So electron moving in this direction can be considered as a current in the opposite direction. Protons moving in a particular direction will be a current in the same direction of the proton, okay. So basically it's an two current carrying wire, but current is being carried in the opposite direction. So current carrying wire opposite direction means they repel each other. Current carrying wire in the same direction attracts each other. Current carrying wire in the opposite direction, they repel each other. So this concept can be borrowed, that beam of electron, beam of proton can be considered as current, okay. So option B is correct. Don't answer randomly. Option B is correct. Think twice before answering, okay. Now next question. A rectangular coil carrying current is placed in a non-uniform magnetic field. On the coil, the total force is non-zero. force is 0, torque is 0, none of these. Rectangular current carrying coil is placed in a non-uniform magnetic field. The uniform magnetic field is not uniform. This is same question as electric dipole. Okay, this is the same question as electric dipole. Current carrying coil can be considered as a magnetic dipole. Okay, so magnetic dipole in an external electric field, in external magnetic field, it will experience both force and torque. So torque is not 0, force is also not 0. Here torque non-zero option is not given, so force is not 0 would be the correct answer. Yes, A is correct. Yeah, but electrons are negative, protons are positive. Yes, distortion, electrons are positive, that's why electrons are negative, that's why current is opposite direction of the motion. Here both of them are moving in the same direction. So electron moving in this direction is current in the opposite direction, proton moving in this direction is current in the same direction. Okay, that is why opposite current. Okay, now next, a conducting circular loop of radius small r carries a constant current I. It is placed in a uniform magnetic field B such that B is perpendicular to the plane of the loop. The magnetic force acting on the loop is IR square B pi RL B 0 pi R square IB. Conducting loop of radius R carries a constant current I. It is placed in a uniform magnetic field B such that B is perpendicular to the plane of the loop. The magnetic field conducting circular loop carries a current I. It is placed in a uniform magnetic field such that B is perpendicular to the plane of the loop. So this is the current carrying loop. Okay, magnetic field is perpendicular. Okay, so what will be the force acting on the loop? Force acting on the loop. So this will be 0. Okay, if the force acting on this, if you calculate all the average forces acting on this loop, because it's perpendicular, net force acting on it will be 0. Okay, so net force, because magnetic field is uniform, so net force acting on the loop will be 0. Okay, so I will take a 25 to 30 minutes break. 25 to 30 minutes break. Okay, I will be back by 10:35. Okay, 10:35 I will be back. Okay, have your dinner and then come back. Okay, see you. So a lot of you are discussing a lot of things when I was away, right? Sahit is asking, sir, can you please tell that whether all the MCQs come from KSAB question bank only? Exact questions will not come, I always say, but yes, questions related to question bank obviously will come. Okay, so related questions will come and concepts will come, exact question may not come. Okay, clear? Sir, by doing these many questions, how many marks you will get? If you understand and solve, you will get 15. If you just memorize these questions, you may be able to get 8 or 7 or 8. Okay? So if you just memorizing I don't think is a good idea at this stage. Understand, apply it in the exam, you score out of out. Okay? Which one? Chinmay, last question, this one. So here we have a current carrying loop, okay. So current carrying loop can be considered as a magnetic dipole. Easiest way to explain is that it is like a magnetic dipole and magnetic field is in this direction. So magnetic field in this direction, magnetic dipole is also in the same direction. So net force is 0, net torque is also 0. Okay, if the angle is something, there will be a torque, but if the field is uniform, it will always, net force will always be 0. Okay. Rajesh, yes you can. Yes Mohi. After this video, what should we cover for MCQs? Suhani, this is it. This is the Brahmastra of MCQ. All MCQs are there in this lecture. If you watch this video, if you complete this video, your MCQs are sorted. Now I have to pick up little bit pace. We are going little slower. So if you have any questions after 100 question, I will give you 2 minutes to ask questions. Till then, wait. Okay. So after 100 question, I will take few more doubts. But till then, I will only take answers and questions related to these questions, not any general comments. In a moving coil galvanometer, the deflection phi on the scale by a pointer attached to the spring is given by which of the following? So phi is proportional to current I, and it is also, so phi, the deflection in the galvanometer, okay, deflection in the galvanometer, if you have seen galvanometer during your practical exam, okay, that it looks like this, it deflects, it is normally it is at the center, then it deflects by some angle, and that angle is given by some constant into current I. Now what is this galvanometer constant? That is NAB by K. K is the spring constant. Okay, so it will be NAB by K into I. So option C is correct. Option C is correct, not D, not A. NAB by K, NAB by K. Okay, you can also remember Bina by K, Bina by K. Okay, Bina, B-I-N-A. One student told me this. Okay, Bina by K. You can remember this as well. Resistance of an ideal voltmeter is, ideal voltmeter, resistance of an ideal voltmeter. Infinity. Resistance of ideal voltmeter is infinity. The resistance of an ideal ammeter is 0. A charged particle moves in a gravity-free space without change in its velocity. Which of the following combination is not possible? This is also a very important hot question. A charged particle moves in a gravity-free space without change in its velocity. Which of the following is combination is not possible? So the net force acting on a charge in an electric and magnetic field is Q into E plus Q VB sin theta. Now here velocity is constant. Velocity is constant means the net force acting on the charge must be 0. The net force acting on the charge must be 0. Okay, so net force is 0. So net force can be 0 when net force can be 0. Net force can be 0 when these two forces are equal. So QVB sin theta equals to minus Q into E, or V equals to minus QE by QQ cancels B sin theta. Okay, so if E equals to 0, velocity can be 0. Okay, if E equals to 0, B equals to 0. Okay, if B equals to 0, then there is no, you don't need to go into this equation at all. You can say from here as well, E is 0, B is 0, so net force is 0. So this combination is quite possible. Okay, if E is not equals to 0, can this be possible with B equals to 0? Now this is a vector equation, by the way. One small mistake, it should be written in vector form because you cannot use scalar form. Vector addition is 0, so it has to be in vector form, and it will be V cross B. Okay, so now if electric field is there, electric field is not 0, B is 0, okay, and is it possible that velocity remains constant? So force will not be 0. This part is 0. So in this case force cannot be 0, so particle will not be able to move with the constant velocity. Okay, velocity cannot remain constant if electric field is not 0 but magnetic field is 0. Magnetic field 0 means this component is constant, so F equals to Q into E, so that means it will be MA. If that is MA, that means this combination is not possible. The particle will accelerate. What about this one? So this will be our answer actually. Electric field is 0, B is not equals to 0. So if electric field is 0, the net force is Q V cross B. Okay, now it can maintain its velocity provided that V cross B itself is 0. This is a cross product. Cross product can be 0 if the velocity is parallel or anti-parallel. So this is possible, that velocity is constant. This is possible when velocity is parallel or anti-parallel. And this is obviously possible if QE equals to minus Q into V cross B. So that in that case also this is possible. So this is also possible. This one is not possible. If electric field is not 0, magnetic field is 0, that case particle will accelerate and the net force will not be 0. I am explaining it. Okay, so Q into E plus Q into V cross B, this is Lorentz force, electric component, magnetic component. Okay, now if you see that if B is 0, E is 0, definitely net force is 0. Net force 0 means no acceleration. Why force is important? Because our super grandfather Newton said us that if there is a force acting on an object, it will accelerate. So if object is moving with constant velocity, okay, that is without change in its velocity, means constant velocity, then definitely net force has to be 0. Now if B is equals to 0, then this component will be 0, but the electric component will not be 0 because it is Q into E. That means Q is not 0, electric field is not 0, so force cannot be 0. Force cannot be 0. There will be acceleration, there will be change in velocity. But if electric field is 0, that means this component is gone. Only magnetic component is there. Magnetic component individually can be 0, even if B is not 0, because there is a velocity involved. So two vector perpendicular to each other, their cross product is 0. Okay, if you cross them, you will get 0 as your answer. Okay, perpendicular, sorry, not perpendicular, what I am saying, perpendicular dot product is 0. Sorry. Two vectors, when they are parallel or anti-parallel, the cross product is 0. Sine 0, 0. V cross B means BV sine theta. So if sine theta is 0, then this can be 0. So this is possible. Not necessarily this will be 0, but yes, it is possible, quite possible. Here it is not at all possible. Here it is possible in a specific case. And this is also possible if this is 0, this is not 0. This one can be 0, provided that Q into E vector equals to minus Q into V cross B vector. If this is a special case, again a special case, but yes, this combination is possible for electric velocity is constant. Okay, so if this is satisfied, then net force will still be 0. Okay, that is why this combination is not possible for net force to be 0. So remember, this question is talking about constant velocity, which we interpret as constant, no force is acting. And force acting on a charge moving in electric and magnetic field is Lorentz force. Then it is a Lorentz force problem. Okay. Yes, if you have not studied, it will be a time pass, right? If you have not studied, this will be a time pass. Now answer this question. Positive charge is moving in combined gravitational and magnetic field. The charge moves without any change in velocity. If the velocity of the charge is along east, then the direction of magnetic field is along. Positive charge moving in combined gravitational and magnetic field. The charge moves without any change in its velocity. If the velocity of the charge is along east, then the direction of magnetic field. So a charge particle is moving in the east direction. This is east, this is west, this is north, this is south, this is up, this is down. This is a three-dimensional figure. Okay, north, south, east, west, up, down. Okay, so all the directions are important. The particle is moving in this direction. This is the charge particle, and there is a gravity also. So what is the role of gravity? Gravity will try to bring it down. The mg force will try to bring it down, but it says that the direction of the magnetic the velocity is unchanged. So the object is moving with a constant velocity. That means this gravitational force must be balanced by magnetic force. Okay, this gravitational force must be balanced by the magnetic force. So they has to be equal and opposite. So magnetic force is acting on the particle in the upward direction. Now this is the direction of V. What will be the direction of magnetic field such that V cross B is in the upward direction? So V cross B should be upward direction. V is in this direction, V cross B should be upward direction. So the magnetic field must be in the north direction, so that V cross B gives you upward direction. Okay, so it will be in the north direction. Magnetic field must be in the upward direction, so that the net resultant force is in the upward direction. Okay, so drawing the diagram is very essential if you see a such question. Okay, it can be east, it can be west, it can be down, it can be west, but remember that whenever you are solving any question like this, draw the diagram this way. Okay, so north, south, east, west, up, down. Okay, north, south, east, west, up, down. Okay, this is moving charges and magnetism. The chapter is Shivam, it is moving charges and magnetism. Why not? The answer is upward. So net force is acting upward, net force. So when you leave an object in a gravitational field, okay, be it a charge, be it a mass, anything, what force will act on it in the gravitational field? This is earth. So the force acting on this must be in the downward direction, right? This is called gravity, okay? This is called gravity, which is downward direction. Now if the particle is moving without changing its direction, normally if you leave it, if there is no magnetic field, what will happen? You studied in your first PUC, the particle will move in a parabolic motion. Under the influence of gravity, it will move in a parabolic motion, that is called projectile motion. It may not be exact projectile. If it starts like this, if it is starting like this, it will go like this, okay? But it says that it does not change in its velocity, that means direction as well as magnitude. So gravitational force must be balanced by the magnetic force. So gravitational force must be balanced by magnetic force. So magnetic force has to be in a direction other than up, okay? Same direction is not possible. So velocity is in this direction, okay? How can we find cross product of two vector? Use right hand rule. V, first you point your finger in the direction of the first vector, curl your finger so that you get the second vector, final vector. Final vector is known, upward is known, first vector is known, second vector you just need to curl your fingers. Second vector you just need to curl your fingers. Okay, so this is upward, this is east, so this must be in the north direction. This must be the north direction. Okay. Bro, please stop spamming in this chat, okay? If you want to study, otherwise do not disturb in my class, I will not allow it. A charge Q, mass small m, is moving in uniform circular motion under action of a magnetic field B. If the radius of the circle is capital R, then the magnetic moment associated with the charge is given by. A charge small q, mass small m, is moving in uniform circular motion under the action of a magnetic field B. If the radius of the circle is capital R, then the magnetic moment associated with the charge is given by. Okay, charge q is moving uniform circular motion. Suppose this is the uniform circular motion. Magnetic field is B. Okay, radius is given by capital R. Okay, you have to calculate the magnetic moment, small m. When 214 it will take some time. Okay, so charge q is moving So magnetic moment is given by NIA. Okay, magnetic moment is given by NIA. But here it is only one loop, so it will be simply I into A. So first of all you have to calculate I and you have to calculate area. Now how to calculate I? So charge Q is moving like this. Okay, suppose the velocity of the particle is V, speed or magnitude of velocity. Velocity is obviously directional, but we are considering the magnitude of the velocity, which is V. Okay, that means it is rotating with the speed v, how much time it takes to complete one rotation? One rotation means 2 pi r. 2 pi r is the rotation and the velocity is v. How much time it takes to rotate one complete rotation? That time is given by 2 pi r divided by v. This is a slightly tricky question. Be patient. Okay, time is given by 2 pi r divided by v. Now what is the current? Current is given by charge divided by time. Okay, charge divided by time, that is q into v divided by 2 pi r. Okay, so this is the current. Now you have to multiply it with the area. So how to calculate the area? Q into v divided by 2 pi r times area of the circle is pi r square. It is pi r square. Multiply with pi r square. So pi cancels. R, one of the r gets cancelled. You get q v r divided by 2. Now if you see that here in the option, in the answer, B is given, velocity is not given. So what you have to do, you have to find the magnetic field, velocity in terms of magnetic field. How to do that? Whenever particle is moving in a circular motion, there will be a centripetal force. Centripetal force is given by mv square by r, and that should be equals to the Lorentz force, that is qvb. Okay, so if you compute this, you can calculate the velocity, which is given by q, one of the v will be cancelled, qbr divided by m. Okay, now put this value of velocity in this equation, that is q into qbr into r, okay, divided by 2 into m. Okay, so now you get this as q square b r square by 2m. Very interesting question. Very interesting question. Correct answer is option C. Yes, option C is correct. But very important thing, that when a charged particle is moving in a circular motion, always remember magnetic moment is given by NIA. Now here I is not given. Okay, area you can calculate using pi r square. So I will be calculated using this formula, that charged particle rotating with a velocity v. Charged particle rotating with a velocity v, okay, it will take some time to complete one rotation. That one rotation time is 2 pi r divided by v. From there you can calculate current. Current is charge divided by time, that is qv by 2 pi r. Now use this same formula to calculate the magnetic moment. Now velocity obviously is not given in the question. They have given you magnetic field, so you need to compute this centripetal force with the Lorentz force and calculate velocity, then use that velocity back into this equation. Okay, this is a very interesting HOTS question. Okay, this is a very interesting HOTS question. How long will the live go on? Yes, till we finish 214th question. Okay, till we finish 214 question. We are at 61, so don't disturb. Let's answer. Yes, thank you. Statement number 1. Current carrying wire is placed parallel to magnetic field. The force on it due to the magnetic field is 0. Statement number 2. The net charge on a current carrying wire is 0. Now I explained it. The net charge on a current carrying wire is 0 because if you connect it in a battery, okay, so if some current some electron is exiting via negative terminal, some electrons are exiting by negative terminal, the same amount of electron is coming back to the positive terminal. So net charge in a current carrying wire is always 0. Net charge in a current carrying wire is always 0, even though it is carrying charges. Okay, actually it is the electric field which takes care of the current, not the moving charge. Moving charge is not that important. Yes, charges do move in a particular direction, okay, but net charge in the current carrying wire is always 0. No matter how many electrons exiting from this side, same amount of electron will enter from the positive side as well. That means net charge in a current carrying wire is 0. Current carrying wire is placed in a parallel to magnetic field. The force on it due to the magnetic field is 0. So current carrying wire and parallel magnetic field, they will be 0 because BIL sin theta. Okay, so force acting on a current carrying wire is BIL sin theta, and this will be 0 because theta equals to 0, parallel or anti-parallel theta 0, sin theta 0, so force is 0. So both statements are true, but statement 2 is not correct explanation. There is no relationship between these two statements. These are independent statement. Okay, so both statements are true, but statement 2 is not explanation of the correct one. Correct explanation would be angle between them is 0. Okay, if the angle between them is 0, then force will be 0. Next question. Match the physical quantities of column 1 with column their units in column 2. Current sensitivity, intensity of magnetic field, magnetic dipole moment. Units ampere per meter, ampere meter square, division per ampere. Okay, division per ampere is current sensitivity. Division per ampere is current sensitivity. Sensitivity is always division per ampere, division per volt. Division per volt is for voltage sensitivity. Current sensitivity is division per ampere. Okay, so this is option 1 is matching with C. Intensity of magnetic field, magnetic dipole moment. What is intensity of magnetic field? Intensity of magnetic field is H. Intensity of magnetic field is H, and magnetic dipole moment is NIA. Okay, magnetic dipole moment is NIA. N is number of turns, it does not have any units. Current is ampere and A is area, so ampere meter square is magnetic dipole moment. Okay, so magnetic dipole moment is ampere meter square, so this is option B. That means intensity of magnetic field must be ampere per meter. Okay, so this is option A. CAB. CAB. So correct match is option B. CAB. Now next, physical quantities related to magnetism are listed in the column 1 and dimensions are listed in column 2. Identify the correct match. Magnetic field, magnetic permeability, magnetic moment. Okay, magnetic field, I don't know, magnetic moment. Magnetic moment, I told you magnetic moment is M equals to NIA. So its dimension will be ampere meter square. Unit will be ampere meter square, dimension will be AL to the power of 2. Okay, so magnetic moment you can match. Magnetic moment you can match L square A. Okay, AL square or L square A. Okay, that is magnetic moment. Next is magnetic field, magnetic permeability. Now magnetic field, how to find the dimension of magnetic field? So magnetic field dimension can be calculated. There are multiple formulas involving magnetic field, but there is a shortcut. What is the shortcut? You remember magnetic field inside the solenoid is given by B equals to mu naught Ni. Okay, mu naught Ni. Okay, now if you find the magnetic, you have to find the magnetic permeability anyway. You have to use magnetic permeability anyway, then you can solve it. Anyway, so let us find magnetic permeability. What is magnetic permeability? Force acting between two parallel wires. Always try to relate them to mechanical quantities whose dimensions are well known. Force acting between two parallel current carrying wire is given by mu naught by 2 pi I1 I2 by D into L. Okay, so if you know the length, then this is the force acting between two wires. In fact, we define ampere from this equation, right? So dimension of mu naught can be written as F D divided by I square L. Okay, this is a dimensionless quantity, 2 pi is a dimensionless quantity. So F into D divided by I into I is I square and divided by L. Now put the dimension, mL t to the power of minus 2, distance D is L, I square is A square and L is L. So this L cancels. We get m L t to the power of minus 2 A to the power of minus 2. This is permeability. Okay, this is permeability. So permeability is m L t to the power of minus 2 A to the power of minus 2. So option A. That means magnetic field will be given by this. You can calculate magnetic field using this formula. Okay, 1A less than magnetic moment. Sorry, magnetic permeability. So correct match is 1 with C, 1 with C, both can be possible, 2 with A and 3 with B. So correct match is option D. Okay, yes, don't spam. Only one relation, sir. Only one relation means, see, this is also could be possible answer. Okay, you cannot say that option D because only one relation. Okay, yes, you have to do the dimension analysis, then only you will be able to solve. If you don't know how to find the dimension, suppose they give you a dimension, how to find the dimension, always relate them to known quantities, force, work, okay, work done, force, energy. These dimensions are well known. Okay, force is ml t to the power of minus 2, work energy is ml square t to the power of minus 2, and power is ml square t to the power of minus 3. These dimensions should be embedded in your head. Charge particle of Q is moving with a uniform magnetic field. The angle between the velocity v of the charged particle and the magnetic field B is theta. The trajectory of the charged particle varies with angle theta. Match the following table by choosing appropriate trajectory. So if angle theta equals to 0, it will be a straight line. If angle theta is 90 degree, it will be a circle. If the angle theta is anything other than 0 and 90, it will be a helix. Okay, angle 0 straight line, angle 90 circle, anything other than 90 and 0 will be helix. Okay, so correct match is 1B, 2C, A, B, C, A. So B, C, A. Bachelor of Computer Application. Next, a charged particle is released from the rest at a region of uniform magnetic and electric field parallel to each other. The particle will move in a helix, circle, straight line, cycloid. Answer this very interesting question. We have magnetic and electric field. We are releasing a charged particle. Releasing means just dropping. It is not moving initially. Yes, it will move in a straight line. Okay, because this electric field will accelerate it, but the magnetic field being it parallel to each other, the magnetic field will not allow any force, so it will move in a straight line. Universal property among all substances. Universal property among all substances. This came in 2024 in a board exam. (66A). Yes, diamagnetism is the universal property. Sir, if we read model paper means how many marks we can get? 30 to 40 marks, 35 to 40 marks, not more than that. when the angle between the magnetic moment of a small compass needle and don't ask this question. If you really want to go and study, don't waste your own time. Okay, you should always study. I have done a video on all 3 model paper, go study that. When the angle between the magnetic moment of a small compass needle and the uniform magnetic field in which it is placed is theta equals to 180 degree, the torque on the needle is maximum, the needle is in stable equilibrium, the potential energy of the needle is 0, the needle is in unstable equilibrium. Yes. Flute soul, no. Torque is not maximum. Torque is mb sin theta. My pen is doing some problem. Torque is mb sin theta. So theta 180 means sin theta 0. Torque is minimum. Torque is 0. Okay. Torque is 0 means the system is in equilibrium. But what type of equilibrium? Stable equilibrium or unstable equilibrium? So for theta equals to 0 degree, stable equilibrium. For theta equals to 180 degree, it is unstable equilibrium. Okay, because potential energy is maximum. Potential energy maximum, but torque 0 means it's unstable equilibrium. A magnetized needle placed in a non-uniform magnetic field in general experiences both force and a torque, both a force but not torque, a torque but no force, neither a force nor a torque. Yes, unstable. Correct. Yes, it will experience both force and a torque because it's a non-uniform. It's uniform, only torque, no force. Next, the dimensional formula of magnetic intensity or magnetization is, okay, find also the unit. Dimensional formula for magnetic intensity or magnetization. So as I said that magnetization or magnetic intensity is B upon mu naught. Magnetic intensity is B upon mu naught. Now how to find B due to a solenoid? If you are considering a solenoid, okay, the magnetic field inside the solenoid is given by mu naught Ni. Okay, you can use any formula. This is the easiest formula for this case. Okay, mu naught Ni, and that is mu naught by N. So it will be N into I. Now what is N? N is number of turns per unit length. So N is not dimensionless over here. It is number of turns per unit length. So number of turns per unit length means it will be 1 upon L, and dimension of current is A. So it will be A L to the power of minus 1. Okay, it will be A L to the power of minus 1. That is option B. Its unit will be ampere per meter. Its unit will be ampere per meter. Also, magnetization is M. M and H, they are different quantities, but M and H are also have the same dimension. If the same question is asked using magnetization, then also you can use the same formula, which will be L to the power of minus 1 into A. That is ampere per meter is unit and dimension is L to the power of minus 1 into A. Same as magnetic intensity, which is again L to the power of minus 1 into A, that is ampere per meter. So remember these. Okay, dimension is L to the power of minus 1 into A and unit is ampere per meter. This is a very interesting, important question. The magnetic susceptibility of a material is 100. Its relative permeability is, magnetic susceptibility is 100. We still have around 150. Okay, that's why I am doing it a little faster. Crazy shots, if you complete this, obviously, first of all, your physics exam, you can score 15 MCQs. Okay, 15 MCQs is guaranteed, and also during this discussion, okay, you will make some new friends. You will make some new friends in the chat. I always make friends with the students with whom I teach. Okay, and also Not only that, some concepts maybe you have forgotten, you will be able to understand those concepts, which will be with you for a long run. Okay, even you can, our teacher used to say, I know your generation is different, but our teacher used to say that if you learn this properly, you can teach your grandchildren as well. Okay, anyway, so relative permeability is mu r, and susceptibility given here is 100. What will be the relative permeability? What is the relation? 1 plus or 1 minus? Yes, it is 1 plus susceptibility. Okay, it is 1 plus susceptibility. 1 plus susceptibility is relative permeability. Susceptibility is relative permeability minus 1. Okay, so correct answer is option C, 101. Okay, they are very close, obviously. So if you just make 99 or 100, 1 will be the answer. Okay, but make sure you do it properly. Okay, next, for which one of the following substances the magnetic susceptibility is low and negative? Bismuth, oxygen, iron, sodium. Bismuth, oxygen, iron, sodium. So basically susceptibility is low and negative is for diamagnetic substance. Iron is a paramagnetic, iron normally is a ferromagnetic substance. Oxygen is a paramagnetic substance. Okay, those who have learned in chemistry, oxygen is a paramagnetic substance that can be explained through its electron configuration. Okay, I am not going into the electron configuration. In fact, I forget exact electron configuration by which oxygen turns out to be paramagnetic, but that can be proven. So between bismuth and sodium. Sodium, now if you have doubt, okay, remember that whoever has a lone pair generally are paramagnetic. Sodium has a individual electron, single electron. Lone pair means single electron. If it has a single electron in its outer orbit, high chance that it will be paramagnetic. So sodium is a paramagnetic. Bismuth, okay, being a it is not first of all, it is not a metal, it is a in between metal and non-metal. So there is a high chance bismuth will be a diamagnetic substance. Copper is also diamagnetic, which is very strange. Being copper is a metal, it should have been a paramagnet, but in bulk property of copper, it is a diamagnetic substance. Okay. Next, in the following table, column 1 lists magnetic substances, column 2 lists some magnetic properties of substances. Match the following: diamagnetic, paramagnetic, ferromagnetic. Okay, now mu less than mu naught. Mu less than mu naught is for diamagnetic substances. Mu less than mu naught is for diamagnetic substances. Paramagnetic substances have susceptibility greater than 1, slightly greater than 1, and ferromagnetic substances we generally see domain formation. Domain formation happens in ferromagnetic substances, only in ferromagnetic substances. So match is PRQ. PRQ. Okay, PRQ is the correct match. A with P, B with R, C with Q. Okay, not A, option B. PRQ, not PQR. PQR, if that is a matching, then what is the meaning of giving match the following? It will automatically be matched. The atoms in which kind of magnetic materials have permanent magnetic dipole moment? Only diamagnetic substances, only paramagnetic substances, only ferromagnetic substances, both para and ferromagnetic substances. Okay. Permanent dipole moment. Yes, both para and ferro have permanent dipole moment. Permanent dipole moment for para is weak, ferro is strong, but both have permanent dipole moment. Okay. Which magnetic property is responsible for strong attraction by a magnetic field? Which magnetic property is responsible for strong attraction by magnetic field? Paramagnetism, diamagnetism, ferromagnetism, both paramagnetism and ferromagnetism. 74. Only ferromagnet, not paramagnet. Paramagnet attracted weakly, not strongly. Strong is the domain of ferromagnet. Okay, strong, if it is strong in susceptibility, strong in permeability, okay, strong attraction, it is always ferromagnets. If a magnetic substance is kept in a magnetic field, then which of the following substance moves out of the magnetic field? Semiconductors, paramagnetic substance, ferromagnetic substances, superconductors. Yes, superconductors are example of perfect diamagnets. Okay, superconductors are perfect diamagnets, and diamagnets are always repelled by the magnetic field. That means they move out of the magnetic field. Okay, ferromagnet, paramagnet does not do anything. Semiconductors has nothing to do with magnetic fields. Okay, paramagnet attract weakly, ferromagnet attract strongly. So they will go into the magnetic field. They will not go out. Only diamagnet will go out. Here superconductors are something which is an example of perfect diamagnetism. The ratio between magnetization and magnetic intensity. Magnetization and magnetic intensity, the ratio between magnetization and magnetic intensity is 1 upon susceptibility. Sorry, it is not 1 upon susceptibility. It is equals to susceptibility. Okay, it is equals to susceptibility. Okay. M by H is defined as susceptibility. Okay, magnetization by magnetic intensity is susceptibility, so it is not permeability, it is not relative permeability, it is not a reciprocal of susceptibility because it is susceptibility. Susceptibility is a dimensionless quantity, it does not have any dimension, so its dimension is 0. So it is a dimensionless quantity. Okay, so option C is correct. Sir, paper will be easy. Only known, sir. I did not get. So paper will be not easy, not difficult. Okay, it will be standard paper. 30% of the paper will be easy, and sorry, not 30%, 40% of the paper will be easy. Now if you can consider that as easy, then it will be easy. If you consider 40% will be medium, 20% will be hard. Okay, so that is the standard paper. Compass needle of magnetic moment M is placed in a uniform magnetic field B of such that the angle between them is theta. The ratio magnitude of torque on the needle and the potential energy of the needle is proportional to. A compass needle of magnetic moment small m is placed in a uniform magnetic field B such that angle between them is theta. So torque acting on them is mb sin theta, and potential energy is minus mb cos theta. Okay, now what is the ratio of torque and potential energy? Ratio of torque and potential energy is mb sin theta divided by minus mb cos theta. Okay, so mb gets cancelled, it will be minus tan theta. Okay, now they have asked about magnitude, so tan theta obviously magnitude means minus, you can ignore. Correct answer is option C. Torque on the needle to the potential energy will be tan theta, potential energy to the torque will be cot theta. Okay, sin by cos, yes, correct. Now this is a very interesting question. A very interesting question. I think this question is actually given in your NCERT textbook solved question. Okay, and this based on this this question is written. The following figure shows a small magnetized needle P placed at a point O. The arrow shows the direction of its magnetic moment. The other arrow shows different positions and orientations of the magnetic moment of another identical magnetized needle Q. Which of the following statement is false for the above configuration? So here we have a magnetic needle P. Here we have a magnetic needle P. Here is another magnetic needle Q. Okay, they are placed like this. These are all the configuration. These are all the different configuration of Q. Okay. Now it is said that in configuration PQ1 and PQ2 the system is not in equilibrium. Q1 and Q2. Okay. System will be stable equilibrium for. So false means this is not only diagram based. So this is, here we have 3 correct statement, 1 is incorrect statement. Okay. So let's see. The system will be in stable equilibrium for configuration Q3 and Q6. Q3 and Q6. Stable equilibrium. The system will be unstable equilibrium for 4 and 5. 4 and 5 stable equilibrium. Q6 corresponds to maximum potential energy state among the given configuration. Q6 corresponds to maximum potential energy state among the given configuration. Now let's figure it out. How to solve it? So here we have a magnetic moment. Okay. Now 2 magnetic moments are there, not 1 but 2. Okay. So if 1 magnetic moment, you can, now how to answer this question? There is a shortcut way, because you already know basics about it. Maybe you have not studied magnetic moment in detail, but we have studied electric dipole in detail. Okay, just remember that electric dipole, the magnetic moment is from negative to positive. Okay, magnetic moment is from negative to positive. Electric moment, dipole moment is from negative to positive. So dipole moment and magnetic moment are same. Okay, only the domain is different. One is in electric domain, another one is in magnetic domain. Okay, so now here we have electric field. In this direction. So electric field generally comes in the opposite direction. If you are considering a dipole like this, electric field on the equatorial plane is in the opposite direction. Similarly, magnetic field due to this dipole will be in the opposite direction. That is what we require. Okay, so if you consider this is the dipole, then the electric field magnetic field due to this dipole at this position will be in opposite direction, and because it's in the equatorial plane. This is the dipole, means this is equatorial plane. Okay, this is equatorial plane. Very interesting. I will explain it once more. So listen carefully. This is the dipole moment. So magnetic field due to this dipole in this direction. Magnetic field due to this dipole will be in this direction. Magnetic field due to this dipole at this point will be in this direction. Okay, magnetic field due to this dipole will be in this direction. Along the axis, direction of magnetic field and dipole moment are in the same direction. Along the equatorial plane, the direction will be in the perpendicular opposite direction. Okay, so if now you consider all the options again. So if this magnetic moment and magnetic field, they are in the same direction, theta equals to 0, torque will be equals to 0. This is theta equals to 180 degree, torque is 0, potential is max. Okay, this is unstable. This is stable. Stable, unstable. Okay, again opposite direction, unstable. Same direction, stable. Okay, these two cases, neither stable, but potential energy is 0. Perpendicular means potential energy is 0. So for Q1 and Q2, potential energy is 0. Okay, potential energy is 0, but system is not in equilibrium. So obviously in configuration PQ1 and PQ2, system is not in equilibrium. This is a correct statement. The system will be in stable equilibrium for Q3 and Q6. Okay, so for 3 and 6, the resultant directions are in the same direction, so these two will be in stable equilibrium. And 4 and 5, they are opposite direction, magnetic field and dipole moment opposite direction, so these two are unstable equilibrium. So this is also correct. P6 corresponds to maximum potential energy. This is wrong. 6 and 3 potential energy is minimum. 4 and 5 potential energy is maximum. Okay. Surjan PDF will be available after the lecture. Okay, no problem. Fluid soul, this question is there in your textbook NCERT. Okay, if you open NCERT, this question is discussed in the solved problem. It is there in the solved problem. Okay, check the textbook for solved problem. This question is solved in that NCERT, not in a form of MCQ, but this diagram is given and they have explained it. Okay, you can go and check that out. But very interesting problem. Very unlikely for your board exam, but this is there in your model question paper. So in case this comes, you will not be able to cry because it is from model paper. The SI unit of magnetic flux is, SI unit of magnetic flux is Tesla meter square, also known as Weber. Okay, Tesla meter square and Weber are same. So it will be Weber. Statement number 1. The net magnetic flux through any closed surface is 0. The number of magnetic field lines leaving the surface is balanced by the number of field lines entering it. Obviously, net flux 0 means incoming flux should be equals to outgoing flux. So both statements are true and 2 is the correct explanation for 1. Option A is correct. Yes. Hello, Elite Gamer. I will try to close it in 1.5 hours more. Okay. The SI unit of magnetic flux is SI unit, so it depends all on you. SI unit of magnetic flux is Weber. Okay, same question. Next, in electromagnetic induction, the induced EMF in a coil is independent of change in magnetic flux, the time change of magnetic flux, resistance of the circuit, number of turns in the coil. Induced EMF is independent of resistance of the circuit. Okay, induced EMF is N d phi by dt. In fact, there is a negative sign. So it depends on number of turns, it depends on the change in flux, it depends on the time taken to change in flux, but it does not depend on the resistance. Okay, and EMF is induced across the ends moving conductor coil in a magnetic field. This is in accordance with Ampere's law, Gauss's law in electrostatics, Gauss's law in magnetism, Faraday's law. Okay, what is the answer? Yes, Gia, correct. Faraday's law. Answer quickly, we can finish quickly. The direction of current induced in the loop ABC as shown in the figure. Okay, don't say that you have not seen this question. So here we have a current carrying wire. Okay, it is current carrying wire. So this is the direction of current. So magnetic field will be into the page of the paper. Due to this current carrying wire, magnetic field will be into the page of the paper. Into the paper means cross. Out of the paper means dot. Okay, so into the page of the paper. Now, if current is constant, magnetic flux linked with the coil does not change. So no induced EMF. So along ABC, if constant is wrong, okay, because if there is no change in flux, magnetic flux, change in flux will be 0, induced EMF will be 0. Constant current means flux is constant. Okay, now what will happen, we will only evaluate one of them and we will see which one is correct. Suppose the current is increasing. If the current is increasing in the wire, then the induced EMF will oppose this magnetic field. Okay, so flux line going into the page will increase and the induced current will such a way it will oppose that motion. That means the induced current will flow from ACB such that the induced magnetic field is outside. Okay, if current is increasing, the coil will oppose this increase and it will move in a direction such a way that the magnetic field is outside the paper. So it will be in this direction. Okay, and so it will be in the clockwise direction. That means the field will be outside the page of the anti-clockwise, sorry, not clockwise, anti-clockwise. So it will be outside the page of the paper. So ACB if it is increasing. So ACB if it is increasing, but here it is given ACB if it is decreasing. So this is definitely wrong. ACB if it is increasing, so this is also wrong because it should be ACB, not ABC. But if the current is decreasing in the circuit, then it will try to increase that current. So it will now move in the clockwise direction so that magnetic field is into the page of the paper. So along ABC if it is decreasing. You always evaluate one of them. You evaluate either increasing or decreasing, the answer will automatically, you will get the answer automatically. You don't need to think twice. Okay. It is already done, one piece. It is already done. Model paper, all three model paper in one video, it is already done. Okay, check the videos at least, right? Sure. I have to do paper discussion, Bunny. Yes, flute. The dimensional formula for inductance is, L. What is the dimension formula for L? Now again I will teach you one more trick. Okay, energy stored in an inductor, is given by half Li square. If you don't know this, you will have to use a multiple formulas, lot of different relations. Try to remember everything. Your exam will be over, you will not be able to answer this. So either you memorize or you use improvisation. So energy stored in a inductor is given by half Li square. Energy stored formula is well known, which is mL square T to the power of minus 2. mL square T to the power of minus 2, and that is equals to half into inductance into ampere square. Okay, so dimension of inductance is mL square T to the power of minus 2 A to the power of minus 2. If you know this, this is very easy. If you don't know this, it will be very, very tricky. So correct answer is option B. Okay, and if you don't know it, you can find it using any mechanical relation, energy, force, relationship with energy stored, energy or force or work done, you can find it. Okay, remember this trick. This is a trick. This is valid for your KCET exam as well. Inductance of the coil is independent of geometry of the coil, medium inside the coil, current through the coil, the number of turns of the coil. Very interesting. Tell me. C also. In this case C also. Both are same. There may be some mistake. I think while copying, the person who copied this question made a small mistake. Okay. No. C is not same. This is minus, this is plus. No, not C. C is plus here. Okay. C is plus here. C is not same. Inductance of the coil is independent of, yes, distortion, not same. Sir, from where to do 2 and 3 marker? 2 and 3 marker, see, I have done endgame 2 and 3 marker. So endgame 2 and 3 marker, it was done the week before your exam. Okay, it is there available in our playlist. Go check, go to our channel, click on playlist. First playlist is physics playlist. There you will get all the 2-3 marker long video, endgame physics, endgame 2-3 marker. There all the important 2-3 markers are done. Okay, if you don't have time, you just want to do the suggested 2-3 markers, check my yesterday's passing package. I think today morning's passing package. There all important 2-3 markers are done. Not all questions, but important ones are done. Okay, if you want all 2-3 markers, go to our playlist. There you will find all 2-3 markers. Okay, it is independent of current through the coil. Okay, inductance depends on mu naught, number of turns per unit length, area, L, N square L. Okay, so this is the formula for mutual inductance. So it depends on geometry. Obviously, geometry means area, length. So that it depends on that. Medium inside the coil, yes, there is mu r also. So it depends on the medium inside the coil. Number of turns also it depends. Only current through the coil, it does not depend. The phenomena of induction of an EMF in a coil due to change in current through the same coil is called mutual induction, self-induction, motional EMF, induction of magnetic field, same coil, self, same coil, self, multiple coil, mutual. Which physical quantity plays the role of electrical inertia? Self-inductance. Electrical inertia, self-inductance. Yes, correct. Now next, if the current flowing through a coil is doubled, the magnetic energy stored in it is also doubled, becomes halved, becomes 4 times, becomes 1/4 the initial value. Okay, if the current flowing through a coil is doubled, the magnetic energy stored by it is also doubled, becomes halved, becomes 4 times, becomes 1/4 of initial value. Okay, magnetic energy stored is given by half Li square. So if you double the current, energy stored will be 4 times. Energy stored will be 4 times. Yes, yes, correct, Yusuf. Match column 1 with the appropriate options from column 2. Self-induced EMF, EMF induced in a rod moving in a magnetic field, AC generator, transformer. Motional EMF, electromagnetic induction by changing the orientation of the loop, mutual inductance, back EMF. Okay, self-induced EMF is called back EMF. This is S. Okay, EMF induced in a rod moving in a magnetic field, it is called motional EMF. So this will be P. AC generator works by electromagnetic induction by changing the orientation of the loop, that is AC generator, and transformer works under the principle of mutual inductance, so this will be R. Okay, so SPQR, SPQR, SPQR. So option A is correct. Next, in an AC generator, when the plane of the armature is parallel to the magnetic field, plane of the armature is parallel to the magnetic field, okay, both the magnetic flux and EMF are 0, both magnetic flux and EMF are maximum, both magnetic flux and EMF are maximum, both magnetic flux and EMF are 0. Okay, magnetic flux is 0 and EMF is maximum, magnetic flux is maximum and EMF is 0. So when magnetic field is in this direction, okay, and the coil is in this direction, so that means, so magnetic field and coil, they are actually like this. In this case, okay, no field lines actually passing through it. When it is exactly perpendicular, then all the lines are passing through it. But when they are flat like this is a 2-dimensional figure, consider it's a two-dimensional figure, so it is no line is actually passing through this. So area is 0 in this case. So magnetic flux will be magnetic field into area, which is equals to 0. So magnetic flux is 0. What about EMF? EMF is given by epsilon m sine omega t. Okay, omega t is the angle. So here magnetic field is in this direction and the plane is perpendicular. Plane is perpendicular, right? Why perpendicular? Because angle to the plane is always perpendicular to the coil. Okay, if you consider a plane, the magnetic the area vector of the plane is always perpendicular to the plane. Okay, that means omega t is 90 degrees. Okay, so EMF induced is actually the maximum EMF induced. A maximum, if you forget what is epsilon m, is NAB omega. Okay, this is the maximum value. It is not required in this question, but you can, good to know. Okay, so magnetic flux is 0, EMF is maximum. Magnetic flux is 0, EMF is maximum. Very interesting question. Okay, put little more in carefulness if you see similar question. Okay, be little bit careful. When flux is 0, EMF is maximum. When flux is maximum, EMF is 0. Okay, now the configuration shows a long straight current carrying wire placed along the axis of a circular conducting ring. When viewed from above, the induced current in the ring is clockwise if the current through the wire is increasing. Okay, so if the current through the wire is increasing, then induced current in the ring is clockwise. If the induced current in the ring is anti-clockwise, the current through the wire is increasing. The induced current in the ring is clockwise if the current through the wire is decreasing. There is no induced current in the ring even when the current through the wire is changing. Somu Chavan, FIB we are not doing. FIB I believe is much easier compared to MCQs. (92A). No. See, the mistake that you are making is, this is the current carrying wire. What is the magnetic field? Magnetic field are concentric spheres, concentric circles. Okay, that means what is the flux linked with this loop? Flux linked with this loop is 0. No field line is there inside, and even if there are field lines, they are confined or outside. So change in flux through the loop is not happening. Change in flux will happen only if the flux lines are passing like this. They are parallel. Flux lines are parallel to the loop. So flux lines are parallel to the loop means flux linked is 0. So flux linked is 0 means no induction. No induction, okay, because field lines are parallel with the loop. So if this is the loop, field lines are also inside or outside, no matter it is increase or decrease, it's a closed loop, so flux change is 0 anyway. Okay, flux change is 0. If it is going into the page, coming out of the page, that is considered to be flux. So if the loop is on the right hand side or left hand side with the face parallel to the wire, then it will be having some flux linked with the coil. Here flux linked is 0. So no induction happens. Now answer this question. The following figure shows a conducting rod moving towards left, okay, on a rectangular conduction loop. The whole setup is placed in a perpendicular magnetic field pointing in the plane of the paper as shown. The direction of induction current in the left part is anti-clockwise, okay, and direction of the induced current right part is clockwise, direction of induced current in the left part is clockwise and right part is anti-clockwise, direction of induced current in both part is anti-clockwise, there is no induced current in the left part. So there will be induced current, okay. So let us consider here we have a wire moving in this direction, magnetic field is into the page of the paper, okay, and into the page of the paper means, and it is moving in this direction, area decreasing in this case, area increasing in this case. So there will be an induced EMF in this, induced EMF in this, okay. Now based on this positive and negative, the loop, this rod will maintain its polarity. So if it is moving in this direction, it will be moving in the opposite direction. So if one is clockwise, another one will be anti-clockwise, that much is sure, okay. Now which one will be clockwise, which one will be anti-clockwise? Let's see. Both part cannot be anti-clockwise fluid. Both part cannot be anti-clockwise. Either it will be one part it will be clockwise, one part it will be anti-clockwise, because in one case area it is increasing, one case it is decreasing. Okay. Now what is the formula for induced EMF? Formula for induced EMF is BVL, okay. So when the area is decreasing means what? Area is decreasing means flux linked with this coil is decreasing. Flux linked with this coil is decreasing means it will induce a current which will try to increase this magnetic field. So this will be in the clockwise direction. This will be in the clockwise direction. In this case, magnetic flux linked with this coil, it is increasing. Okay, more number of field lines is passing. More number of field lines it is passing. Okay, do not ignore the do not see that only two lines are there means there is no other field lines. Field is present over here. Here the field, as the wire is moving here and here, closer and closer, okay, the area decreasing means flux is decreasing. Flux decreasing means the induced current will be in the clockwise direction. Okay, why? Because it will try to enhance this magnetic field, whereas in this case it will be trying to decrease this magnetic field by producing a current in the anti-clockwise direction. But through this wire, magnetic field will always be in the same direction. Okay, so this is anti-clockwise, this is clockwise. Okay, do not think too much about it. This kind of question, very rare chances of that this exact question will come. So direction of induced current in the left part is clockwise, and right hand side it will be anti-clockwise. So Tarun is correct, yes. Okay, now if the angular speed of the rotating armature of an AC generator is increased, angular speed of the rotating armature of an AC generator is increased, the frequency of AC increases while its peak EMF remains the same. Peak EMF increases while frequency of the AC remains same. Both frequency and the maximum EMF increase. Both frequency and maximum EMF remains the same. So what is frequency? Frequency is 2 pi omega. Omega is what? Omega is angular speed. So if you increase angular speed, frequency increases. Direct relationship. What about the peak value of induced EMF? Peak value of induced EMF is NAB into omega. So if you increase omega, peak value also increases. Okay, so both frequency and maximum EMF increase. Both frequency and maximum EMF increase. Consider the following two statements. Statement number 1. When two coils are wound on each other, the mutual induction between the coil is maximum. Mutual induction does not depend on the orientation of the coils between the two statements. Statement 1 is false, statement 2 is true. So here reason assertion is not there, but whether both of them are true or not, that is you have to understand. Answer this. statement 1 is true, statement 2 is false. Okay, it does depend on the orientation. So if how the coils are wounded one over another, based on that the flux linkage happens, and based on the flux linkage we get mutual induction. Okay, so mutual induction do depend on the orientation of the coil. Okay, so when the two coils are wound one over another, the maximum flux linkage happens, so mutual induction is maximum. Okay, so both statements, statement 1 is correct, statement 2 is false. The use of laminated core in a transformer reduces energy loss due to flux leakage, coil resistance, hysteresis, eddy currents. So laminated core means, if you have seen a transformer or have seen a diagram of a transformer, transformer is basically not a solid block. Okay, transformer generally looks like this. Okay, this is a three-dimensional figure of a transformer. Here we have small pieces. Okay, and they are all then glued together to form the transformer. Here we have one coil, here we have another coil. Okay, one is primary, one is secondary. Now why this arrangement is done? This is called laminated core. Laminated core means they are separated from each other. Instead of having a solid iron block, they are manufactured single very thin slices, and then in between we put some insulating material and then we link them. That is to avoid eddy currents. Eddy currents is the reason. To avoid eddy currents we have to use laminated core. Now eddy current, what is eddy current, what is hysteresis, those are not part of the syllabus, so I am not going into detail. The frequency of AC is increased, the impedance of the LCR circuit continuously increases, continuously decreases, first increases and then decreases, first decreases and then increases. Frequency of AC is increased, the impedance of the series LCR circuit. What happens to the impedance? Very interesting question. It will be medium, 40% increase, 40% easy, 40% medium, 40%, 20% difficult. So let's see. So basically impedance, what happens in impedance? Okay, what is impedance, by the way? Impedance is square root of R square plus XL minus XC whole square. Okay, and if you see, impedance is equals to resistance, exactly equals to Z equals to so when the resonance frequency. So if you plot the impedance graph, okay, you will see that XL decreases like this. Okay, sorry, XC decreases like this, XL increases like this, and resistance is constant. Okay, resistance is constant. And if you plot the graph of impedance versus frequency, the graph is like this. Okay, exactly opposite to that of the resonance graph. Okay, exactly opposite to that of the resonance graph. If you plot it, okay, it first decreases, becomes a minimum value, and then again increases. Okay, this minimum value is the resistance. This minimum value is the resistance. Okay, it starts with a higher value, it slowly decreases. Exactly at resonance, the resistance is minimum, impedance is minimum, and again it starts increasing as you cross the resonance. Okay, so first decreases, then increases. Impedance exactly opposite to that of current. Current is maximum at resonance. Any other point, current is always less. But for impedance, it first decreases, then increases. This is the impedance versus frequency graph. Okay, this is the individual component graph. And in terms of current, if the same question is asked, that what happens to the current, current is given in your textbook. Current is given in your textbook, it happens like this. Current becomes maximum at resonance, so it first increases, then decreases. But impedance first decreases, then increases. It does not continuously Zinat Khan, it might come. It might come, yes. You solve all the MCQs in the question bank, you will be able to answer 15. That's what we are doing. Power factor of a purely resistive circuit. Power factor of a purely resistive circuit 0, unity, infinity, 0.5. Please don't spam Zinat. It will be unity. Yes, power factor is cos phi. Okay, phi is 0. Phase difference is 0. Power factor is 1. At resonance, series LCR AC circuit behaves like a purely capacitive, purely resistive, purely inductive LC circuit. Good morning, Komal Kaushik. Yes, we have crossed 12. So it will be purely resistive circuit. At resonance, LCR circuit behaves like a purely resistive circuit. You should not say good morning, happy midnight. Okay. The power factor of a series LCR circuit is maximum when XL equals to XC. XC, I think XC equals to 0. XL greater than XC, XL less than XC. The power factor of a series LCR circuit is maximum power factor is 1 when circuit is in resonance, that is XL equals to XC. Okay. 100th question at 12 AM. Okay, now let's continue. We have scored 100, century scored. Let's continue quickly. Which one of the following statement is wrong? AC can be easily and efficiently stepped up or stepped down. It is economical to transmit DC over large distances. The average value of sinusoidal alternating voltage over. So I found my answer. I am answering it. You can check the other options as well. So wrong statement means it is not economical to transmit DC. Okay, transmitting AC is much more economical than transmitting DC because you cannot change the voltage for a DC current. Okay, so it is not economical to transmit DC. So this is my wrong statement. I found it. I am marking it. Okay, we have to go a little faster. Double speed. In a purely capacitive circuit, if the frequency of AC is doubled, the capacitive reactance will be. Capacitive reactance is 1 by 2 pi Fc. So if you increase the frequency, capacitive reactance will be halved. Okay, so capacitive reactance will be halved. If frequency is doubled, capacitive reactance will be halved. Try to use the formula if required. The phenomena of resonance exhibited by an AC circuit only if both L and C are present in the circuit. Only if both L and R are present, R and C are present, R is present. Phenomena of resonance happens only if both L and C are present. R is optional. Even if R is 0, the circuit can show resonance. Okay, but if only R is present, this is purely resistive circuit. You don't need any resonance. Power is always maximum. The dimensional formula of LC is, L is self-inductance, C is capacitance. What is the dimensional formula of LC? LC sometimes is also called time constant. Okay, why it is called? Let's see. So we know that resonance frequency is given by 1 by 2 pi square root of LC. Now what is frequency? Frequency is 1 upon time. Frequency is 1 upon time, number of oscillations per unit second. So it is 1 upon time. It's hertz. Hertz is nothing but second inverse. Unit of frequency is hertz, which is nothing but second inverse. So the dimension of frequency is 1 by t. So dimension of 1 by square root of LC must be 1 by t. So dimension of LC is equals to t. So dimension of LC equals to t square. So it is t square. Square root of LC is called time constant of the circuit. Okay, because it gives you a time. Okay, it is t square. 104, it is not t to the power of minus 2, it is t square. Okay, it will be t square. Now next, at resonance the voltage across resistance is equal to, if you are in doubt always use mathematics, that is much easier, especially for this kind of questions. At resonance voltage across resistance is equal to voltage across L, voltage across C, applied voltage, the sum of voltages across L and C. So at resonance voltage across resistance is equals to applied voltage, voltage across L and C are equal, and if you add them it will be 0. Column 1 lists the component through which alternating current is passed. Column 2 lists the quantities related to column 1. Match column 1 with column 2. Pure resistor, pure capacitor, pure inductor, series LCR circuit. Okay. Current leads the voltage by pi by 2. Current is leading in capacitive circuit. Current leading in a pure capacitor. So this is option P. Okay. The current lags behind the voltage by pi by 2. That means it must be the inductor. Reactance of the circuit is independent of the frequency of AC. So for a pure inductor, reactance or impedance, okay, reactance or impedance of the circuit is independent of the frequency. It is only possible when it is a pure resistor. Average power dissipated over a complete cycle is non-zero, that is for LCR circuit. Now both A and D can be matching with option S, okay, but the reactance of the circuit is independent of frequency is only possible in a pure resistor. So this is more common for this. This option is can be mapped with A and D both, but reactance for series LCR circuit, reactance depends on frequency, okay, except for resonance, reactance depends on the frequency. So AR, R, B is P, B is P, C is Q, and D is S. R, P, Q, S. R, P, Q, S. Option B is correct match. Okay. Tricky question. Make sure if you see this kind of question, you answer after reading the entire question. Okay. Ganesh Patil, if you do all the current electricity numericals are tricky. If you can solve circuit theory related questions without any problem, then you will be able to score. Okay. I don't recommend current electricity because even if you practice 10 problems in the exam, if you make a small mistake, you can still be getting 0 marks. Okay. Part marking is very uncommon in current electricity. A light bulb and an open coil inductor are connected to an source through key as shown in the figure. The switch is closed and after some time an iron rod is inserted into the interior of the inductor. As the iron rod is inserted, the glow of the bulb will increases, decreases. What happens? So here we have a inductance. Okay, inductance means inductor obviously L, and if you insert an iron rod, okay, the inductance increases. Inductance increases means inductive reactance also increases. Okay, so inductive reactance increases means current in the circuit decreases. Current in the circuit decreases. Current decreases means the bulb glows less brighter. Okay, so the brightness of the bulb decreases. Okay, the brightness of the bulb decreases. Inductance increases, brightness decreases. Now, based on this question, there was a question in last year's paper, but exact this question did not came. The question was slightly trickier than this one. The following figure represents variation of voltage and current of an AC with time. The solid line represents instantaneous voltage. So this is voltage, okay, and this is current. Okay. From the figure, we can infer that the circuit is purely resistive, purely inductive, series LCR with XL greater than XC, series LCR with XL less than XC. Very interesting question. So what we will be doing, we will be taking this 0 point. We will be taking the 0 point. At 0 point, if you see that current is here, voltage is 0. That means current is ahead in phase than voltage. Current is leading the voltage. Okay, current is leading the voltage. So current is leading the voltage at 0 point. Current is ahead. Okay, it is not 0. Okay, voltage is 0. Okay, voltage is 0. No, sorry. Wait, Mari. So we don't need to study the 0 point, we need to study this point. We need to study the maximum point. So at maximum point, if you see, this is the voltage, this is the current. So when the maximum of voltage happens, the maximum of current is happening before, okay? So current is lagging. Here current is lagging. Current is behind in time, voltage is ahead in time. Okay, voltage is, if you see, this is the difference, voltage is ahead in time. Okay, now this difference is definitely not 90 degrees. 90 degrees means if this is maximum, this will be 0, then it is 90 degrees. Okay, if it is a maximum, if it is when this is maximum, this is minimum, then it is also 90 degree phase difference. But in this case, this is maximum and these two maximums are not related. Maximum and minimum are not related, and that means here definitely it's an LCR circuit. If the circuit is like this, or circuit is like this, then it is 90 degrees difference, phase difference. Okay, phase difference is not 90 degree in this case. Phase difference is somewhere between 90 and 0. That means it's a series LCR, and because current is behind, we will say current is lagging. Current lagging means it is XL greater than XC. XL is greater than XC. So series LCR circuit with XL greater than XC. Rajesh, stop spamming please. I am putting you on timeout. Yes, sorry. So if he repeats again, I will ban him. Okay. The input voltage to a pure inductor is V equals to Vm sin omega t. Then the current in the circuit is I equals to Im sin omega t. Pure inductor. Okay, it's a pure inductive circuit. Pure inductive circuit means current is lagging behind. Current is lagging behind. Okay, current leading means capacitor, current lagging means inductor. So current is lagging by the voltage. Voltage is omega t, so current will be omega t minus pi by 2. This is the lagging behind. So correct answer is option C. Okay, if it is a pure resistance, this is for pure resistance. This is for pure capacitor. This is for pure inductor. Remember this. For pure capacitor, it is plus. For pure resistor, in phase, exactly in phase, phase difference is 0. So here omega t means here will be also omega t. Okay. If capacitance current is leading, inductance current is lagging. Lagging means minus. Leading means plus. In a series LCR circuit, the L and C are interchanged. The resonance frequency of the circuit will increase, decrease, remains the same. There will be no resonance. Series LCR circuit, L and C are interchanged. The resonance frequency of the circuit will Derive the relationship between electric field and electric potential due to a point charge. Tarun, it was done multiple times. So it is like this. Here we have a say this point is at potential V, this point is at, this is a equipotential B at potential V minus delta V. The distance between them, say delta L. Electric field always points from higher potential to lower potential. This is the direction of electric field. Okay, if you take a small charge Q, what is the work done? According to the potential, the work done is given by charge into difference in potential, that is V minus delta V minus V minus V cancels, you get minus Q into delta V. This is the work done to move the charge from here to here, whereas work done to move the charge in terms of electric field, it will be given by force into displacement. Now what is force? Electric force is given by Q into E into delta L. Okay, so these two work done must be equal. So these two work done must be equal means what we can say is minus Q delta V equals to Q into E into delta L. Q cancels, so E equals to minus delta V by delta L. Now the minus sign indicates that electric field points from higher potential to lower potential. Okay, so this derivation. Y Rx, what pole you want? If he is coming back to another alt, I will block him. Okay, we will try to implement that. Maybe during your KCET we will try to implement that. Right now we do not have that technology right now with us, but definitely we can talk to our management and we can arrange that. In a series LCR circuit, the L and C are interchanged. The resonance frequency of the circuit will increase, decrease, remains the same. There will be no resonance. Okay, L and C interchanged, resonance frequency does not change. Resonance frequency is very simple. It is 1 by 2 pi square root of LC. Okay, so as long as values are same, resonance frequency does not change. It's a series combination. Displacement current produced due to constant electric field, constant magnetic field, changing electric field. Okay, displacement current is produced due to changing electric field. Okay, next, fast. The expression for displacement current is epsilon naught d phi e by dt. Okay, these are, so if it is a simple answer based question, I am answering it. If it is required explanation, I will explain. Next, choose the false statement. Electromagnetic waves are produced by accelerated charged particles. Correct statement. For electromagnetic wave, E naught by B naught is C. This is also correct statement. Electromagnetic waves are transverse in nature. This is also correct statement. Electromagnetic waves can be deflected by electric field and magnetic field. No, electric field and magnetic field cannot deflect electromagnetic waves. Okay, so option D is wrong. So option D is false. Next, out of the following options, which one can be used to produce a propagating electromagnetic wave? A chargeless particle, an accelerating particle, a charge moving at a constant velocity, a stationary charge. Okay, only a accelerating charge can produce propagating electromagnetic wave. Which electromagnetic wave used in long range communication? Okay, in long range communication, radio waves are used. Okay, gamma rays, infrared rays, microwaves, they are not used in long range communication. Radio waves are used in long range communication. The increasing order of wavelength of infrared, microwave, ultraviolet and gamma rays. Increasing order means smallest of them is gamma. Okay, gamma has smallest wavelength. So first is gamma. Next is ultraviolet. Next is infrared, and last is microwave. Okay, this is the increasing order. So here it is the smallest wavelength, microwave has the highest wavelength. So gamma rays, ultraviolet, infrared, microwave. Option B is correct. Okay. Next, the wavelength range of X-ray. Wavelength range of X-ray. Someone answer this. Less than 10 to the power of minus 3 nanometer, 10 nanometer to 10 to the power of minus 4 nanometer, 400 nanometer to 1 nanometer, 0.1 nanometer to 0.1 meter to 0.1 millimeter. Capacitance of a capacitor is A epsilon naught by D. So capacitance is directly proportional to area, capacitance is inversely proportional to distance between the plates. So here is the capacitor, distance between the plates is D and area of the plate is area A. So you just need to write it in words. Okay, if you are writing in like this, you have to mention what is A, what is D. Okay. Obviously it will be based on blueprint. 117D. No. So this is in meters. Okay. It will be, see, 400 nanometer to 1 nanometer. It is the range of ultraviolet. Okay. This is the range of X-ray. This is the range of UV rays. Okay. This is UV ray. This is gamma ray. Okay, this is X-ray, this is UV, and I think this is the range for microwave or radio wave. Okay, I think radio wave. I think radio waves. I am not sure about this one, but less than 10 to the power of minus 3 nanometer gamma ray, 10 nanometer to 10 to the power of minus 4 is X-ray, 400 nanometer to 1 nanometer is UV ray. 400 nanometer is basically the violet ray. So anything smaller than that is UV ray. Okay. Yes. The angle between electric field and magnetic field in an electromagnetic wave is, angle between electric field and magnetic field in an electromagnetic wave, it is 90 degrees. The ultraviolet region of the electromagnetic spectrum lies between X-ray and visible. Okay, ultraviolet is between X-ray and visible is ultraviolet. So gamma, X-ray, ultraviolet, visible range, then infrared, then microwave, then radio wave. Okay. Statement number 1. Displacement current goes through a gap between plates of the capacitor. When the charge on the plates of the capacitor does not change, the displacement current arises in the region in which the electric field is constant with time. So both statements are wrong. Okay, so if capacitor is charging only, then displacement current is there, and displacement current is basically changing electric field. It is the rate of change of electric field linked with the coil. Okay, so electric flux in the actual sense. Anyway, so electric field is constant means electric flux is constant. That means the displacement current is 0. So both statements are wrong. The electromagnetic wave suitable for radar system is microwave. So radar system, it is not, microwave is not given here. I think you need to answer infrared. Okay, radar system, microwave is more used. If microwave is not given, then closest one is infrared. Okay. Next, electromagnetic waves are transverse in nature. The electric and magnetic fields in electromagnetic waves are perpendicular to each other in the direction of the propagation. So that is the reason that it is called transverse. So electric field and magnetic field, they are perpendicular, and this is also perpendicular, mutually perpendicular to the direction of propagation. Okay. So that means statement 1 and 2 both are true, and it is the correct explanation. So if the thing that is producing the wave vibrate in the perpendicular direction, then it is called a transverse wave. So this is a transverse wave. The velocity of electromagnetic waves depends on the velocity of electromagnetic waves depends on the electric and magnetic properties of the medium. Velocity of electromagnetic waves in free space is constant. Velocity of electromagnetic waves depends on the electric and magnetic properties of the medium. Okay. Velocity of electromagnetic waves in free space is constant. Both statements are correct, but statement 2 is not explanation of statement 1. Okay, so basically velocity of EMF means speed of light in different medium is different. Okay, speed of light in vacuum is constant, which is 10 to 10 to the power of 8. If you go to water, it will be less than that, because it depends on the electric and magnetic property of the medium, of course. Okay, speed of light is given by, in vacuum it is 1 by mu naught epsilon naught, and for any other medium it is given by 1 by square root of mu into epsilon. Okay, mu is the permeability of that medium, epsilon is the permittivity of that medium. So speed of light, be it in vacuum or any other medium, it depends on the magnetic and electric property of the medium, but definitely here this is definitely not the explanation. So both statements are true, but it is not the correct explanation. Speed of light according to Maxwell's equation is given by, already told you, 1 by mu naught epsilon naught in free space. It has to be mentioned in free space or in vacuum. Okay, speed of light in vacuum is given by C equals to 1 by mu naught epsilon naught. Statement number 1, infrared radiation plays an important role in maintaining the average temperature of Earth. So Nanu 3 marks question bank in the Odidene 6 chapters select marti endeni. So exam all 6 questions nu cover agutta sir. So yes, you can, but if one chapter is difficult, then what you will do? You read 6 chapter, fine, but if one question is difficult, you will not have any extra option. Okay, you are saying five question you have to answer. You are saying 6 chapters I have studies, I have one extra question. Yes, that is one strategy, good strategy, but if in case there are 2 questions which are difficult from the 6 chapters that you have studied, then what you will do? Then you need to recall some other questions which may not be you are familiar with. So I recommend the 8th chapter I suggested. Check my 3-day strategy video. There I have suggested 8 chapters. You do all the questions from those 8 chapters. Your life will be settled. All 2 marker, 3 marker, 5 marker, everything you can answer. Okay. 124 is a JE question. No. Rohan, after the exam, immediately after exam, once your exams are over, you will start getting your class 11th portion in KC90 as well as KC30. Okay, both will run parallelly. Okay, because obviously your board exams is here. How can I complete PU1? Statement number 1, infrared radiation plays an important role in maintaining the average temperature of Earth. If infrared radiations are sometimes referred to as heat waves. Okay, both statements are correct, but I am not sure if you can say that this is the correct explanation of the option 1. Okay, any object when they are heated, they emit infrared radiation. That is why it is called heat waves. Okay, and when during the day Earth becomes hot, during the night the hot Earth emits infrared radiation to the space, and that's how Earth cools down. Okay, so average temperature of Earth is maintained like this. So both statements are true, but statement 2 is not correct explanation. Okay, it will be far-fetched if you say that this is the correct explanation of option 1. Okay, so both statements are true, but statement 2 is not correct explanation of option statement 1. In refraction of light, sin I by sin R equals to constant. This is Snell's law. Okay, obviously option D. For total internal reflection of light should travel from denser medium to rarer medium. Light should travel from denser to rarer medium. So what happened in okay, I answered you. They said to find dimension formula in 124 question. Dimensional formula, this one, dimensional formula. If they ask you dimensional formula of this, it will be meter per second. So this is, remember that if they ask you what is the dimension of 1 by mu naught epsilon naught, okay, that will be meter per second, okay, because this is velocity. And if they ask you dimension of mu naught epsilon naught, then it will be second per meter, okay. And in case they ask you this kind of quantities, that will be, you need to do mathematics, okay. 1 by mu naught epsilon naught or mu naught epsilon naught, both are very simple. Square also you can find, okay. Okay, understood. In JEE they ask the dimensions of this, okay, got it. Okay, got it. An object of finite height is placed in front of a concave mirror within its focus. It forms real enlarged image, a real diminished image, a virtual enlarged image, a virtual diminished image. So concave mirror within its focus, so it will form a virtual enlarged image. It will be a virtual enlarged image, okay. Now question number 129, the speed of light in a medium depends on angle of incidence, angle of refraction, refractive index, its mass density. Speed of light in a medium depends on only refractive index. It does not depend on angle of incidence or angle of refraction or mass density. It depends on refractive index only. Refractive index of a medium depends on thickness of the medium, angle of incidence, mass density of the medium, optical density of the medium. So basically, refractive index is the measurement of optical density. Higher the optical density, higher is refractive index. Smaller is optical density, smaller is refractive index, okay. So it is basically a measure of optical density. When a light ray travels from rarer medium to denser medium, its velocity increases, velocity decreases, wavelength increases, frequency decreases. So light ray travels from rarer medium to denser medium, okay, velocity decreases. Rarer medium, more velocity, less density, more velocity, more density, less velocity. So velocity decreases. Rarer, higher speed, denser, smaller speed. Snell's law fails in the case of normal incidence. Snell's law fails in case of normal incidence because I is equals to 0, R is also equals to 0. So you cannot find sin I by sin R, okay, both of them are 0, and 0 by 0 is obviously undefined. You cannot even use L'Hopital rule to calculate it, okay. So Snell's law is not valid when both of them are 0, sin I and sin R. So normal incidence means when it is falling along the normal, so both angles are 0. Next, the principle of optical fibers, reflection of light, dispersion of light, is total internal reflection of light, okay. Optical fibers through which you are probably watching me right now. If you are using via Wi-Fi, probably you are watching me via optical fibers. If you are watching in your mobile, then the network nearest tower that is connected to your mobile phone, they are using optical fibers, okay. No flute. According to Newton, maybe I am not sure about Newton's corpuscular theory, it was wrong anyway. When the light travel from because just remember that speed of light in vacuum means the most rarer medium, there is nothing there. Speed of light is 3 into 10 to the power of 8 meter per second, just simple understanding. And this is the maximum possible speed. any other medium, okay, this speed has to be smaller than this. So when light travels from rarer to denser, speed of light decreases, okay, because of cosmological boundary. Okay, this is the maximum speed according to Einstein. This is the maximum speed, and light's maximum speed is in vacuum and in air, almost in air. Okay, slightly less than this, but almost equal to this value. The focal length of lens depends on refractive index of the material, radii of curvature of two surfaces, diameter of the aperture. So focal length of lens depends on n minus 1, 1 by r1 minus 1 by r2. So it depends on refractive index, radii of curvature. Diameter of aperture is not there. Okay, diameter of aperture obviously not there. It can improve the quality of the image formed, but focal length does not depend. So only 1 and 2 are correct. Only 1 and 2 are correct. Diameter of the aperture is not there. Next, two thin lenses of focal length f1 and f2 are in contact. The power of the combination. So two thin lenses are in contact. So power equals to P1 plus P2. Okay, powers normally gets added. That is 1 by f1 plus 1 by f2, which is equals to f1 f2 f1 plus f2. Okay, so power is f1 plus f2 divided by f1 f2. This is the power. Equivalent focal length, it will be f1 f2 by f1 plus f2. This is equivalent focal length. Okay, simple mathematics. The angle of minimum deviation of a prism depends on only angle of prism, only refractive index of the prism, angle of incidence, both angle of the prism and its refractive index. So refractive index is given by sine A plus delta m by 2 divided by sine A by 2. So obviously angle of minimum deviation depends only on the refractive index and angle of prism. So both angle of prism and its refractive index does not depend on angle of incidence. Minimum deviation does not depend on angle of incidence. A ray of light is incident on a glass air interface at an angle greater than critical angle for the pair of media. Then the ray undergoes total internal reflection. If it is exactly equals to critical angle, then it will graze the interface. It is more than critical angle, total internal reflection exactly equals to critical angle, graze the surface of the interface. Next, the magnification of a refracting telescope. Magnification of a refracting telescope is objective by eyepiece. Okay, objective by eyepiece. Refracting telescope is FO by FE. A ray of light is incident on the glass air interface at an angle greater than that of critical angle for the pair of the media. I think I made a mistake. It will be eyepiece by eyepiece by objective. Okay, because eyepiece magnify the image most, so it will be refractive index of the eyepiece by objective. Yes, B, 138B. Let's see. Okay, option A. Yeah, okay, sorry. Microscope, I think it will be FE by FO. Okay, let's leave it. Next, statement number 2. What is your question? What is oblique? Oblique incidence means if the ray is falling like this is called oblique incidence. Any angle which is not 0 or 90 degree, this is called oblique incidence. Statement number, I think this will be statement number 1. Okay, printing error. A convex mirror is preferred over a plane mirror in vehicles to observe traffic coming from behind. So the rear view mirror, we use convex mirror. Convex mirrors have large field of view and images of real object formed by convex mirror are erect. So both statements are true and second is correct explanation. So both is true and second is correct explanation. Why? Because higher field of view means it can form a large area. It can see a large area behind you. If it is a plane mirror, you will not be able to see large area. It is a convex mirror, you can see a large area behind you. Plane mirror will not give you that field of view. The image formed by total internal reflections are much brighter than those of mirror or lenses. In total internal reflection, the light is completely reflected and there is no loss of intensity of light. Obviously, both statements are true and second is correct explanation. Total internal reflection, no refraction happens, right? So entire light is reflected, that's why light appears bright. Next. Two light sources are said to be coherent when both the sources of light emit light of the same amplitude and phase, the same intensity and wavelength, the same speed, the same wavelength and constant phase difference. Okay? Two light sources are said to be coherent when both sources of light emit. Read option in 139. Okay, sorry. Okay. Options are jumbled here. Correct explanation. Thank you, Tarun. Okay. So this will also be wrong then. Both are correct. So option 2 will be correct in this case. Just I think during typing some incorrectness happened. Two light sources are said to be coherent when both the sources of light emit light of same wavelength and constant phase difference. Okay, same wavelength and constant phase difference. Okay, coherent means phase difference. It does not only intensity and wavelength. Intensity and wavelength can be same, but if they are having a phase relationship, then only it is called coherent sources. Okay, coherent sources will always have a phase relation. It can be zero, it can be some constant phase. So as long as it is constant, they are called coherent sources. In Young's double slit experiment with the monochromatic light, how is the fringe width affected if the screen is moved closer to the slit? So here is the double slit experiment you are doing. Okay, if you move the slit closer, if you move the screen closer, what will happen to the fringe width? Now anyway, fringe width directly is not there. Okay, it is there with the position. Okay, position of bright fringe is given by n lambda d by d. Okay, and the fringe width is given by lambda d by d. Okay, so if you decrease the distance between the slits and the screen, then fringe width decreases. Okay, fringe width decreases. Okay, yes, correct. This formula, by the way, is not there in your syllabus. This one is there, this one is not there. Which would be the resultant intensity at a point of destructive interference? If there are two identical coherent waves of intensity I naught producing an interference pattern. So destructive interference means the resultant intensity will be 0 at destruction and resultant intensity will be 4 I naught at point where we will get the maximum intensity. A beam of unpolarized light of intensity I naught is passed through a pair of Polaroids with their pass axis inclined at an angle theta. The intensity of the emergent light is equals to. So we have two Polaroids. The angle between them is theta. The light that incident on this Polaroid is I naught. What will be the emergent intensity? So the intensity of light that is passing through this will be I naught by 2. If it is only one Polaroid, if I naught is known, the intensity of light coming out will be I naught by 2. And this one will be I naught by 2 cos square theta. Okay? So it will be I naught by 2 cos square theta. Coherent meaning, suppose there is a wave. There is another wave. So now suppose when this is at maximum, the other wave is also maximum, this is minimum, this is also minimum, this is also maximum. If this relationship is maintained over a very long time, then these two waves are called coherent sources. Okay, but suppose this relationship is not maintained over time. As you are going ahead in time, it is initially it was constant, but slowly as you see that the relationship is not maintained, it is random, then you cannot say they are coherent. For example, you take one mobile torch, you switch on a second mobile torch immediately at the same time. Okay, these two lights will be completely random motion. They will not have any sync between them. They are actually incoherent. In fact, if you consider a single LED, and single LED is actually not a single point source. If you consider a single LED, it is a multiple point source. And even in that case, all the lights coming out of that LED are not coherent. Even though they are being produced same time, they are not coherent. Okay, because they are being produced by the vibration of the atoms. Electrons are moving in the higher energy state, they are coming back, and because of that you are getting the light. And different electrons are going into different energy states, and they are coming back to the energy ground state randomly, and then you are getting the light. So that's why even a single light source is considered to be incoherent. Okay, only example of coherent beam is laser light. Okay, if you have a thick laser light is an example of coherent source. Laser light, helium light, sodium vapor lamp, they are considered as coherent sources, because in those cases they are designed such a way that all the electrons coming back to the ground state at the same time and producing a very synchronized light. That is why they are called coherent light. Okay, clear? Tarun, you can score. Yes, of course. Let me complete. We have another 70 MCQs. Let me complete quickly in 30 minutes. Help me. Help Madi. 145. To observe sustained interference pattern on a screen placed at a suitable distance in Young's double slit experiment, which of the following conditions are necessary? Sources of light should be coherent, sources of light should be narrow, sources of light should be very close. So to observe a sustained interference, sources of light must be coherent. There is no doubt. If you want to observe interference, the sources of light has to be coherent. Sources of light should be narrow. Yes, narrow gives you a brighter fringe. Okay, and sources of light should be very close. It should be close enough so that it is in the order of the wavelength, so that is also important. So all A, B and C are required to observe a bright sustained interference. Okay, bright sustained interference, you need that sources should be coherent, sources should be narrow, obviously, otherwise you will not be able to observe the interference. Sources of light should be very close as well. Okay, so basically these is the narrowness. So the width of the opening should be very narrow. Okay, and the distance between them should be also very small. Next, according to Huygens principle, the speed of the secondary wavelets is same as the wave. Secondary wavelets same as the wave. Next, when a point source of light is placed at the principal focus of a thin convex lens, the shape of the emergent wave front is spherical, convergent wave front, spherical, divergent wave front, plane wave front, cylindrical wave front. Okay, when the point source of light is placed at the principal focus of a thin convex lens, the shape of the emergent wave front is, so thin convex lens, and we have a point source. So after it falls on the convex lens, it becomes parallel. Okay, this is on the focus. So when they fall on the lens, they become parallel. So basically the wavefront is plane wavefront. The wavefront is plane wavefront. Okay, if it is placed, remember that if it is placed on a convex lens, same question is asked, but a plane wavefront falls on the lens. Plane wavefront means infinite, the object distance is infinite, then they will converge and it will give you a spherical wavefront, but in the reverse order. Okay, this is a KCET level question. Okay, this is a board level question. So this is the difference. Next, the shape of the wave front for light coming from a distant star. Shape of wavefront from a light coming from a distant star. Distant star lights are parallel to each other. That means they are plane wavefront. This is also plane wavefront. Next, the principle of superposition of wave applies whenever one source of light falls on a screen, one source of light moves across a screen, two or more sources of light illuminate the same point. Okay, this is the principle of superposition. They has to fall on the same point. Two or more waves, they has to fall on the same point. If they illuminate two different points, there will be no principle of superposition. Okay, we will have constructive interference if path difference is delta x equals to n lambda, delta x equal to n plus 1 lambda by 2. So path difference is multiple of lambda, that is considered to be constructive interference. So delta x equals to n lambda. These are wrong. To observe diffraction, the size of the obstacle must be of the order of the wavelength. Should be of the order of the wavelength. If the it does not matter, then you will get a complete bright fringe. If it is too small, then obviously you will not see anything. If it is too large, you will just see a bright spot without any diffraction. Okay, the gap or opening to observe diffraction, the opening should be of the order of the wavelength. Two lights each of intensity I0 are used in Young's double slit experiment. The intensity of the interference maxima is, two lights each of intensity I0 are used in Young's double slit experiment. The intensity of interference maxima is 4I0. Minima is 0, maxima is 4I0. Okay, the derivation is there, 4I0 cos square phi by 2. For intensity maximum, this is 1. For intensity minima, this is 0. When a compact disc is illuminated by small source of white light, colored bands are observed. This is due to diffraction. This is not due to scattering. This is due to diffraction. Anup, I have studied 1/2 of the first lesson. Can I score about 46 in physics if I start from tomorrow? You go and check my passing package. Watch that passing package. You will score 45 plus. One video, and if you get some time, prepare this MCQs. You can be very close to 50 plus as well. Okay. When the compact disc series illuminated, this will be diffraction. Just 30 more minutes, guys. I will complete it. By 1:30 it will be over. While both light and sound show wave character, diffraction is much harder to observe in light. This is because speed of light is greater, light does not require a medium, wavelength of light is far smaller, waves of light are transverse. Okay. Well, both light and sound show wave character. It is much difficult to observe diffraction in case of light because the wavelength of light is far smaller. Wavelength of light is far smaller. Which of the statements are correct with reference to single slit diffraction pattern? So in single slit diffraction pattern, fringes are of unequal width. Because they are asking correct, make sure you are reading the question carefully, because if I am doing it a little faster, so sometimes if it is incorrect, you read the first question, you think this is correct option, you mark it, you did not read the other option. Don't do that. Make sure it is correct or incorrect, true or false. Those kind of question can give you trouble. Light of certain frequency and intensity incident on a photosensitive material causes photoelectric effect. The incident radiation is made exceedingly dim. The photoemission will still happen, okay? The photoemission will continue, but saturation current will decrease. Saturation current depends on intensity. Photoelectric emission does not depend on intensity. As long as the frequency is higher than the threshold frequency, you will get photoelectric emission. Next, in photoelectric effect, the time lag of electron emission is of the order of 10 to the power of 9 to 10 to the power of minus 9 to minus 8 second. Okay, both can be possible. I am answering this one. These two both, this actually it is 10 to the power of minus 8 to minus 9. Okay. SI unit of power. SI unit of power is watt. Okay, capital W or small watt. James Watt, by the name of James Watt, the unit is dedicated to him. Okay, answered last one, yes. Now this can also be a correct answer based on, obviously, as I mentioned, in exam you do not get these close options. Okay, both can be considered to be correct. Based on some substances shows 10 to the power of minus 9 second, some substances shows 10 to the power of minus 8 seconds. So both are correct. Okay, I am taking the smallest possible value. Okay, but in exam if you see this kind of options, it will not be there. The de Broglie wavelength of a moving particle is independent of dash of the particle. De Broglie wavelength of the moving particle is independent of charge. It depends on mass, depends on speed, and mass into speed is momentum, so depends on momentum as well. Okay, next, emission of electrons from a metal surface by heating is called thermoionic emission. Heat is thermal, thermal means thermoionic. In photoelectric effect experiment, only the frequency of incident radiation is increased, then maximum kinetic energy of photoelectron decreases, stopping potential increases, the photoelectric current increases, photoelectric current decreases. Now photoelectric current is independent of the frequency. Photoelectric current depends only on the intensity of light. So definitely these two are wrong. Now maximum kinetic energy is directly proportional to the frequency. So that means if you increase the frequency, kinetic energy will increase, not decrease, but stopping potential will increase by the formula EV naught equals to H nu minus phi naught. Okay, so if you increase nu, V naught increases. Okay, phi naught is constant. The sufficient energy by the electron to overcome the attractive pull of metal surface is called the sufficient energy by the electron to overcome the attractive pull is called work function. It's called work function of the surface. The particle behavior of light was confirmed by following experiment. A. H. Compton on scattering of X-rays from electrons, Albert Einstein for photoelectric effect, Millikan for charge of electrons, J. J. Thomson's on discharge tube experiment chose the correct answer. Okay. Now 1, 2 and 3, all of them are actually particle nature of particle behavior. Oh, sorry. J. J. Thomson's discharge tube experiment is not involving particle nature or wave nature of light or electron. Okay, it is only it was electron was discharged and then it was E by M was measured. So only 1, 2 and 3. Only 1, 2 and 3. Even though Einstein's photoelectric effect is wave nature of particle, not directly particle nature of light, but yes, in the other sense, when light is falling, it is being absorbed as a particle, so this is also correct. So Compton's X-ray scattering, Millikan's electromagnetic wave generation and Einstein's photoelectric effect. These three are the process where particle behavior of light is displayed, not on J.J. Thomson's discharge tube. So 1, 2 and 3 are correct. Next, photon energy is independent of intensity of radiation, frequency of radiation, wavelength of radiation, none of these. So photon energy depends on frequency. Frequency dependence means wavelength, but intensity of the light is not dependent on photons energy. Photons energy is what? Photons energy is h into nu. That is frequency. That is hc by lambda. This is wavelength. So depends on frequency, depends on wavelength, but does not depend on intensity. Okay, so photon energy is independent of intensity. Next, passing package, you can score 40 to 50 marks, not 50 to 60. 40 to 50 marks you can score. Yes, you can score up to 50 marks easily. In a photon particle collision, which of the following is conserved? Only total energy is conserved, only total momentum is conserved. Both total momentum and total energy are conserved. Neither total momentum nor total energy is conserved. Photon particle condition, total energy is conserved, total momentum is conserved. Okay, momentum and energy both will be conserved. Okay, momentum is conserved anyway, and because it's a energy and particle collision, total energy will be conserved, not kinetic energy. Total energy is always a constant quantity, so total momentum and total energy will be conserved. The gathering and focusing mechanism of light by eye lens. Gathering and focusing of light by eye lens is wave nature of light. The receiving the light in our retina is particle nature of light. Macroscopic particles in our daily life do not show wave properties because macroscopic particle means you, me, my pen, this lecture board, everything do not show any wave particle. We cannot travel like a wave like it is shown in the movies. Why so? Because their wavelength is negligibly small. Their wavelength is not zero, but it is very, very small. So you can ignore their wavelength. And basically, even if you consider that I am a wave, I will not be able to move very fast. Okay. The following statements relating wave theory to explain photoelectric emissions are: statement number 1, maximum kinetic energy of photoelectron is directly proportional to frequency of light. The frequency of radiation can change the saturation current in photoelectric emission. Okay, both 1 and 2 are true, but 2 is not the correct explanation of 1. Both 1 and 2 are true, but 2 is the correct explanation. 2 is not the correct explanation. This is correct explanation. 1 is true, 2 is false. Both 1 and 2 are false. Let's read the options once more. The maximum kinetic energy of photoelectron is directly proportional to frequency of light. Yes. So K max equals to h nu minus phi naught. The frequency of radiation can change the saturation current in the photoelectric emission. So frequency of radiation cannot change the saturation current, only intensity of light can. So 1 is true, but 2 is false. The slope of stopping potential V0 versus frequency nu in Einstein's photoelectric emission. So slope of stopping potential, sir, how much marks I can score if I study only model papers of board? 35 marks. 35 marks. Notes 1, 5, 3, 4. So if you have not read 2-3 marker question, Bunny, check my 2-3 marker video already there in the live, and if you still don't have time, tomorrow Aditi ma'am will do live 2-3 marker question. You can check that as well. Okay. The slope of stopping potential V0 versus frequency nu in Einstein photoelectric emission. So slope is EV naught equals to h nu minus phi naught. So V naught equals to, V naught is stopping potential, which is equals to h upon E into nu minus phi naught upon E. So the slope is h by E. Slope is h by E. Next, in a photoelectric experiment, the wavelength of incident radiation is reduced from 6000 angstrom to 5000 angstrom. Then the frequency will decrease. So frequency is what? Frequency is speed of light divided by wavelength. So if you decrease the wavelength, frequency will increase. Stopping potential, and stopping potential on the other hand is directly proportional to frequency because it is h nu minus phi naught. So frequency increasing means stopping potential is increasing. Okay, stopping potential will increase, kinetic energy will increase, work function is constant. Work function is constant for a given metal, it will not change. So these two are wrong. Next, photoelectric emission is emitting electrons on applying heat, electric field, magnetic field, light. Photo means light. Okay, photo means light. The condensed matter and dense gases at all temperature emit. Sir, how much I can score if I study MCQ from question bank? Ravi Kumar, you can answer all the questions. Wait for 20 minutes, it will be over. Don't worry. I know it dragged a little longer because a lot of you are asking same question. Okay, that is why it dragged a little longer, but I will try to close it as long. I am also not sleeping, right? I am not sleeping. How can you sleep? You have exam. Okay, the condensed matter and dense gases at all temperature emit electromagnetic radiation due to high temperature, oscillations of atoms and molecules, head-on collisions between atoms and molecules, none of these. So condensed matter and dense gases at all temperature emit electromagnetic radiation due to oscillations of atoms and molecules. Oscillations of atoms and molecules, they oscillate. Okay, head-on collision does not matter but because of the oscillation it emits radiation. The source of alpha particle in Geiger-Marsden experiment, it is bismuth 214. Okay, Rutherford Geiger-Marsden experiment. Okay, bismuth 214. According to classical theory, we are already at the atom chapter. Next, nuclei and then semiconductor. We will be over. 3 more chapters to go. The electron will fall into the nucleus. An accelerated electron emits radiation in circular path. Both statements are true and 2 is correct explanation. Okay, so accelerated electron moving in a circular path is accelerating and slowly it will jump into the center. Okay, that's why electron will fall into the nucleus. So as the energy is emitted, it will lose energy and continuously it will lose energy. It will fall at the nucleus. Next, the detector in alpha particle scattering experiment is coated with silver nitrate, phosphorescent, barium sulfide, zinc sulfide. Detector in alpha particle is coated with zinc sulfide, which is also a phosphorescent. Okay, so both B and D can be answered. Zinc sulfide is more accurate. Name is given phosphorescent, not any other phosphorescent, but zinc sulfide itself is phosphorescent. Okay, next, the light emitted by mercury vapor lamp due to statement number 1, interaction between the individual atoms, the average spacing between the atom is large. Okay, mercury vapor lamp is basically your halogen lamp, which is used in functions, etc. The large lamp which is used. Now, interaction between individual atoms is obviously not the cause. Because mercury vapor lamp, when you are heating the mercury vapor lamp, the electrons in the mercury vapor, they goes into the higher energy state and then they comes back. That is the reason. And obviously because it's a vapor of mercury, even though it is saturated, average spacing between the atom is large. So statement 2 is true. Okay, no, not even statement 2 is true, because in vapor lamp it is a saturation is there. Okay, mercury vapor lamp means it is a saturation of mercury, so all the atoms are very close to each other. Okay, it's basically a vacuum created, and then you put some mercury into it, so mercury becomes vaporized, and it is a saturated mercury vapor. So both 1 and 2 statement, both statements are false. Okay, anyway, this is not super important, this question. From kinetic theory, the size of the atom was to be. From kinetic theory, size of the atom, if I am not mistaken, it will be 10 to the power of minus 10 meters. Okay, can someone confirm me? Check this question number 176. Saku, no problem. Okay, I have to finish it. I will. So even if you study the MCQs, you can only answer 15 questions, Vignesh. You will not be able to answer all the questions. If you study the numericals in question bank, all the numericals, good luck, you will score all the 15. Okay, option A, 10 to the power of minus 10, yes, okay. So from kinetic theory, the size of the atom was 10 to the power of minus 10. Next, the size of the atom is about dash times larger than the size of the nucleus. Okay, size of the atom is 10 to the power of 5 to 6 times more, I think, or 4 to 5. So either this one or this one. Again, my brain is also stopped working. Okay, so check this question as well. Size of the atom is about dash times larger than the size of the nucleus. No, I have to come. I wanted to take rest, but if I take rest, the class will go longer. I don't want to take longer. Only 30 questions more left. So let's complete that, and then I will be taking rest. Yes, it is enough. Go, don't spam here. Go and study. Okay, don't spam in the chat. Study yourself. Okay, size of the atom. So it is 10 to the power of 5. Yes, I am correct. 10 to the power of 5 to 10 to the power of 6. 10 to the power of 5 to 10 to the power of 6. Okay, you are saying 5 to 6, I think, right? Okay, anyway, I am marking it option D. Either C or D, both can be answered correctly. Let's move on. The alpha particles are the nucleus of helium plus 2 atom. Alpha particles are the nucleus of helium plus 2 atom. Rutherford particle scattering experiment determined the size of the nucleus. It determined the size of the nucleus, 10 to the power of minus 10, right? The negative sign of electrostatic potential in the energy of an electron. So negative energy in the sign of the electron, that is En equals to minus 13.6 divided by n square. This negative sign indicates that electron is bound to the nucleus. Potential energy of electron is unstable. Electrostatic force in the negative r direction. Kinetic energy of electron is constant. So basically it signifies that electrostatic force is in negative r direction. So electrostatic force when the electron is orbiting, so it is in the negative r direction, that is in towards the center. Positive r is this is positive r, this is negative r. Okay, so electrostatic force in the negative r direction, that can also be signified, or also it can say that electron is bound to the nucleus. The emission of line spectrum is a characteristic of molecule, solid, and atom, a liquid. So line spectrum is characteristic of an atom, not molecule. It's the atom which emits a particular line spectrum. The emission of line spectrum serves as fingerprint. It's a fingerprint of gases. So if you observe emission spectrum coming from a very distant star, and when you match it with the Earth's emission spectrum, you can identify what are all the metals present, what are all the gases present in that distant star or distant galaxy. That can be determined using the emission spectrum. So that is why it is called fingerprint of gases. Next, Bohr's atomic model imitates Sun Earth system, Earth Moon system, Sun planet system, Sun comet system. It Bohr's atomic model imitates Sun planet system. Okay, Sun Earth system, Earth Moon system, all can be answered, but okay, this is the closest answer, Sun planet system. The principal quantum number for Bohr radius. Principal quantum number for Bohr's radius, n square equals to 1, n equals to 1. Okay, this is the principal quantum number. The minimum energy required to free the electron from the ground state of the hydrogen atom is called ionization energy. This is, you have also studied in chemistry. The minimum energy required to free the electron is called ionization energy. Nucleus of an atom whose atomic mass is 24 consists of, so atomic mass is given 24, so it can have 11 protons, 11 electrons, 11 protons and 13 neutrons. So if you see this, if you add them, okay, they will be 24. Okay, now generally proton number and neutron number, protons number should be smaller than that of neutron or equal at least. Okay, so here you can say 11 protons and 13 neutrons. Okay, or this one. Okay, because here it is mentioned nucleus does not have any electrons. A nucleus does not have any electrons. So 11 protons and 13 neutrons is the correct answer. Okay, 11 protons and 13 neutrons is the correct answer. Electrons are not present inside a nucleus, only protons and neutrons are present. Generally protons are either be smaller or equal to that of neutrons. Proton number cannot be more than neutron. If that is so, then nucleus will be completely unstable. Isotopes are atoms having same number of protons but different number of neutrons. Okay, isotopes basically same number of protons but different number of neutrons. Okay, same number of neutrons and different number of protons are called isotone. This is isotone. And same number of protons and neutrons, total number same means that will be isobar. Radius of nucleus of a mass number A is given by a to the power of 1/3. Radius is a to the power of 1/3 into r0. Okay. Which of the following is correct for nuclear forces? Short range, attractive and charge independent, short range, attractive, charge dependent, long range. So long range is wrong, short range is correct and charge independent is correct. So it is obviously attractive and short range and it is charge independent. So option A. Yes, correct. Quickly. Density of any nucleus is, help me with this. What is the density of any nucleus? It is constant. Hi, Saida. Okay, you are saying B. Okay, because you are saying B, I am going with B only. Okay, you can check this in the textbook. This is a constant value. Okay, density of nucleus is constant, which will be 2.29 into some 10 to the power of value. Okay, I am guessing yes, it is correct because it is the highest value. So that from that logic, I can say this is the correct. Binding energy of a nucleus is energy given to its nucleus during formation, total mass of nucleus converted into energy units, energy required to break the nucleus in its constituent nucleons. That is binding energy. Binding energy is the energy which is binding the nucleus together. You supply that extra energy, nucleus will break. The binding energy per nucleon is maximum for, binding energy per nucleon is maximum for iron. Okay, Fe. Binding energy per nucleon is maximum for iron. Any other element, binding energy is less. For effective nuclear forces, the distance should be okay. For effective nuclear forces, distance should be in the order of femtometer, around 0.8 femtometer to 2 femtometer. It is attractive. Less than 8 femtometer, 0.8 femtometer, it is repulsive, and then it becomes 0 after 2 femtometer. So it will be of the order of femtometer, that is 10 to the power of minus 15 meter. Okay, remember that. In the energy graph, this is the region where it is attractive. This is the region where it is attractive. This is the region where it is repulsive. So 0.8 Fermi. This is around 2 Fermi. Okay. This is the region where the nuclear force. This is the nuclear force graph. Okay. Energy negative means nuclear force is attractive. The alpha particle is the nucleus of an atom of helium. Radioactivity is self-disintegration process, spontaneous process. So both B and C is correct. Radioactivity is when something breaks, some unstable atoms breaks apart automatically. Okay, so basically it's a self-disintegration. Also it's a spontaneous process. You cannot predict it. Radioactive substances emit alpha ray, beta ray, gamma ray, that is all of the above. Fusion reaction takes place at high temperature because atoms are ionized at high temperature, molecules breaks up at high temperature, nuclei break up at high temperature, kinetic energy is high enough to overcome the repulsion between nuclei. So this is the correct answer. So fusion means 4 different positive atoms, nucleuses, they come together and fuse to form a larger positive nucleus. So you need a very high kinetic energy so that they collide to each other and they stick together. That means you need a very high kinetic energy, and that is why to conclude fusion you need a very high temperature. The explosion of the atomic bomb takes place due to nuclear fission, nuclear fusion, scattering, thermionic emission. Explosion of atomic bomb is nuclear fission. Okay, hydrogen bomb, nuclear fusion. Energy generated in star is nuclear fusion. Fusion of light nuclear. Fusion of light nuclei. Hydrogen combines to form helium, and that gives us the energy that is being produced in our sun. And this process will continue till all the hydrogen is over in the sun. Once the hydrogen is over, then the star will start to collapse at first, then it will convert into a red giant. You can read that in the internet if you are interested later on. Fusion reaction is initiated with the help of high temperature. Okay, almost Gia, 200 is over. Now 14 more questions are there. Valency of an impurity added to germanium crystal in order to convert it into a p-type semiconductor. Valency of impurity added to germanium crystal in order to convert it into a p-type, we require 3 valency. To convert it into n-type, we require 5 valency. The majority charge carrier in p-type are holes. A semiconductor doped with a donor impurity. Semiconductor doped with a donor impurity is p-type, n-type, npn type. Donor impurity means it is giving electron, so that means it will be n-type. Donor, n-type, acceptor, p-type. A p-type semiconductor can be obtained by adding arsenic to pure silicon, gallium to pure silicon, antimony to pure germanium, phosphorus to pure germanium. Okay, arsenic, antimony and phosphorus, all of them are pentavalent. So all of them will give you n-type. Only gallium is a trivalent element, so this will give you a p-type semiconductor. The thickness of depletion layer is approximately A depletion layer is approximately 1 micrometer. Okay, depletion region means when you are forming a p-type and n-type, in between there is a region, this is called depletion region, which is very small, of the order of micrometer. The diffusion current in a PN junction is greater than drift current in magnitude. So diffusion current in a PN junction is greater than the drift current in magnitude when the junction is forward biased, the junction is reverse biased, the junction is unbiased. If the junction is unbiased, drift current and diffusion current are same. If the junction is forward biased, drift current is more than diffusion current. Only if the junction is reversed biased, diffusion current is reverse current. So reverse current will be more only if the junction is reverse bias. Forward bias means drift current, conventional current will be more. Okay. Next, when a PN junction diode is reversed biased, electrons and holes are attracted towards each other and move towards depletion region. Electrons and holes move away from the junction of depletion region. Height of the potential barrier decreases, no change in the current takes place. So electrons and holes move away from the junction, okay, and depletion region increases, so option B is correct. The cut-in voltage for silicon diode is approximately, cut-in voltage for silicon diode is approximately 0.7 volt. Okay, not band gap. Band gap of silicon is 1.1 electron volt, but cut-in voltage is 0.7 volt. Remember that. Cut-in voltage and band gap are different. PN junction diode is used as amplifier, rectifier, oscillator, modulator. PN junction diode is used as rectifier. The output of the full wave rectifier is pure AC, pure DC, pulsating DC, pulsating AC. It is pulsating DC. Pulsating DC means it is pulsing. Okay, it is pulsing with time. So this is called pulsating AC. Pulsating DC. Why it is DC? Because only positive. Everything is positive. No part in the negative half. So with time the voltage is only positive. That is why it is pulsating. Pulsating means it is increasing. Okay, ripple is there. Okay, ripple means the waves is there, so it is pulsating DC. How does a pure DC looks like? Pure DC is this. This is pure DC. Next, the forbidden energy band gap in conductors, semiconductors and insulators are Eg1, Eg2 and Eg3 respectively. The relation is, so conductors band gap is almost 0, so band gap of conductor is smallest. Okay, semiconductors is in between these two, so Eg2 is next. It is greater than, obviously Eg1 is smallest. Eg3 is for insulator, it will be highest band gap, greater than 3 electron volt. So correct answer is option C. Easy question, just think a little bit, you will be able to answer. The energy band gap in germanium and silicon is in electron volt respectively is, so energy band gap in germanium and silicon in AV, for silicon it is 1.1, for germanium it is 0.7. Okay, so this is the correct answer. This is silicon, this is germanium. This is in electron volt. Okay. Next, in a semiconductor the concentration of electron is 8 into 10 to the power of 14 per centimeter cube, and that of holes is 5 into 10 to the power of 12 centimeter cube. The semiconductor is, you don't need to do any mathematics here. Okay, remember electron concentration is more than hole concentration, that means it is an n-type semiconductor. Don't confuse, sir, I have to do a calculation at this stage. No, electrons more than holes, so this is a n-type semiconductor. Which of the following energy band diagram shows the n-type semiconductor? N-type semiconductor has a donor level which donates the electron to the conduction band. So this is the donor level which donates electron to conduction band. This is acceptor level. Acceptor level means it takes electron from the I think there is a reverse order. It will be a conduction band, this will be valence band. Okay, I think somehow the order is reversed. Okay, so this will be P type. Anyway, this is wrong. This will be P type, this will be N type. So for N type semiconductor, this is correct. Okay, this level will be very close to conduction band. Conduction band is always on top than valence band. So I think they just try to confuse you. Okay, so this is the end of this session. Thank you. 212 is wrong. Option is A. No. Okay. Sorry. I read silicon and germanium. So I read silicon and germanium. My mistake. It will be germanium and silicon. So germanium and silicon is this. Yes, correct. Sorry. I wrote that this is silicon, this is germanium, but I read the question little wrong. Germanium and silicon. Germanium is 0.7, silicon is 1.1. Yes, correct. Okay. Okay. Good night, guys. See you tomorrow evening 5 p.m. I will be taking a very important live. Bye and see you tomorrow. And sweet dreams.